Good morning, everybody, and welcome to the very first session of e-Rum2020. My name is Mirko Signorelli, and I am one of the members of the organizing committee of e-Rum2020. And in my daily life, I work as biostatistician and R programmer at the Medical Center of Leiden University. Actually, the fact of being a biostatistician who works with R is the main reason why I'm going to chair the first invited session of today, which will focus on 2 of the 6 tracks that compose our program. The first track that we will cover in this session is about the use of R in the life sciences. The second one is also called R Word. We have a lineup of 4 interesting talks for this session. So what will happen now is that I will invite each invited speaker to come on the stage and present their work, exactly in the same way as it would happen in a non-virtual conference. Each talk will last 15 minutes, so in total this session will last for about 75 minutes. At the end of this session, each speaker will be available in a dedicated session for 20 minutes, and there attendees will be able to engage with the speakers and ask them questions. Now, without further ado, I would like to welcome on stage our first speaker, Britta Velten. Britta is a postdoctoral researcher at the German Research Center, where she develops statistical methods and computational tools to integrate multimodal data for a better understanding of complex biological systems. Hi, Britta.
Hello, everyone.
So the floor is yours.
Yeah, it's really a pleasure to kick off the first session here at e-Rum2020.
It's a pleasure to have you here.
I'll share my screen. I hope you see everything. So in my talk, I would like to show you some R applications from the life sciences and present you one package that we've developed, Multi-Omics Factor Analysis, that we use as a probabilistic framework for the scalable integration of multimodal data. So why are we interested in multimodal data? Working in life science, we basically aim to understand the molecular mechanisms that underlie the functioning of an organism. For this, we have to study diverse classes of molecules that make up the cells, which in turn are the basic building block of every living organism. And thanks to recent technological advances, we can now use modern technologies to get a comprehensive quantitative characterization of a given class of molecules, and the resulting data is often referred to as omics data. If you've never worked with omics data before, you can just imagine it as being some large, typically very high-dimensional data with molecular features measured in a set of samples. However, often a single omic is not enough to really understand a complex biological process, like, for example, a disease such as cancer or a developmental process. Here, multiple molecular layers play together in shaping such a process, and therefore we also have to study multiple omics jointly in order to get a comprehensive understanding. And that's where multimodal data comes into play. And just to give you one motivation where this is of importance, let's turn to clinics. Here in clinics, the heterogeneity across patients in terms of disease onset, disease progression, or treatment outcome is still a major challenge because it makes it very difficult to decide for the optimal treatment of a patient. While some patients respond very well to a certain drug, other patients do not respond to it or suffer severe side effects. And with multi-omics approaches, we hope that we can gain a better understanding of this patient-to-patient heterogeneity and eventually enable personalized treatment decisions on a molecular basis. However, working with multi-omics data can be really challenging. First of all, there's usually a collection of very heterogeneous data as it were measured with different technologies and therefore also come along with distinct statistical properties and an inherent structure that is given by these different molecular layers as well as by different sample groups that can, for example, be different age groups of patients or also due to the experimental designs, for example, some samples that were treated or samples that were not treated. In addition, the data typically displays complex correlation structures and hidden confounders can impact our measurements, which we are not aware of. And due to the sheer size of the data, we need to make sure to use appropriate regularization strategies and have algorithms that are also scalable to large data sets that can contain hundreds of thousands of molecular features or samples. And finally, there's also often a lot of missing values in the data, and we want to have interpretable approaches so that we can later on go back with our results to domain experts, biologists, clinicians, and together have a look at the results. And in order to tackle these challenges and facilitate working with multi-omic data in the life science, we built an R package called Multi-Omics Factor Analysis that is based on the Bayesian model for the unsupervised integration of multimodal data. So the basic idea is that MOFA performs a structured matrix factorization to infer a joint low-dimensional representation of multimodal data. So this is displayed here on the bottom. You can see that we have this complex data set that is structured in the different molecular layers, which I also call views here, and different groups that correspond to distinct sample groups. And we jointly decompose it into a set of latent factors that is shared across all molecular layers and weight matrices that are specific to each of the molecular layers. And as the different molecular layers come with different properties, we also implemented different noise models for each of the views so that we can choose the noise model for a view that is most appropriate for such data. To ensure interpretability of the approach, we use a range of different sparsity priors, both on the factors and on the weights, such as the automatic relevance determination prior and the spike and slab prior, which makes it easy to determine for each factor in which of the molecular layers this is important and in which sample groups it's important. To ensure scalability, we base the inference in this Bayesian model on a stochastic variational Bayes approach. And the algorithm for the variational Bayes approach is actually implemented in Python. And we've used the reticulate package to interface this back to our R framework, which works really nice in our case. And to make sure that researchers can also input their data into this framework easily, we interface with a range of different bioconductor and R classes, such as, for example, multi-assay experiment, which is a really nice container for such multi-omic data sets, or CovidR, which is a popular tool in the single-cell field. So once a model is trained, we, of course, want to understand what these factors are actually about. And for this, we have a range of different downstream analysis functions implemented in the package, which are also available in the Shiny app, where people can just upload their trained model and then explore the results in an interactive manner. So first of all, what we typically do is to see which of the factors explains variance in which of the views and which of the groups. So such a variance decomposition often gives a very clear picture thanks to these sparsity priors we put onto the model. So for example, in this case, you would see that the first factor is only important in 2 of the sample groups and most important in 2 of the molecular layers. Next, we can, of course, use the factors to visualize our samples in the latent space. For example, here we see that in the latent space spanned by 2 latent factors, we see a nice clustering of the samples in 3 distinct groups. And then at the end, we, of course, also want to get to the molecular signature of the factor to see what biological process is actually captured by the factor. And for this, we can look at the weight matrix of a factor in a given molecular layer. And again, thanks to sparsity priors on the weight matrix, this often gives a very clear picture where only a few number of molecular features, for example, genes, are important for this factor and seem to be the driving genes behind such variation we see in the data. And if a single gene does not tell us too much, we can also jointly aggregate information from multiple of the molecular features, for example, by conducting enrichment analysis of the weights to test for feature sets, such as, for example, gene sets that are linked to a certain factor. Now, I've showed you the basic principle that is behind multi-omics factor analysis and the R framework. And now I would like to show you 2 applications where we've applied this framework in order to dissect a complex biological system. And the first application is from the field of personalized medicine, where we try to understand the sources of patient-to-patient heterogeneity in blood cancer, or more specifically, chronic lymphocytic leukemia. So for this, we applied the method to 200 leukemia samples that were characterized by 4 molecular assays. We had genomic information on them, RNA sequencing, methylation arrays, and ex vivo drug response assays telling us how the samples respond to certain drugs. And as you can see, not all of the patients were profiled completely. So for example, for the RNA data, we only had a subset of the patients, and that's the missing value structure that MOFA can handle. If we now look at the factor we get from this application, we can see that some factors, like for example, factor 1, is important for all of the molecular layers, while factor 4 is only important in one of them. And if we look into more details on the first factor, we can see that this actually nicely recovers an important clinical marker, which you can see on the bottom left here. So this distinguishes 2 clinical subgroups that are known for this disease, CLL, and is given by the genomic marker IGHV, But we can also link it back to other molecular layers and immediately tell what are the genes that are linked to this distinction between the subgroups in terms of gene expression, and which are the tracks that show differential responses between the patients depending on where they lie on the factor. And also we can use this to refine the clinical marker and also identify outliers like the red point on the bottom, where the biological background of the sample does not correspond well to the clinical label, which might actually be wrong or misleading. And last but not least, we of course also wanted to know whether the factors can be useful to predict the clinical outcome for a patient. And for this, we looked whether the MOFA factors are associated to the time to treatment and can provide an improved prediction compared to models relying on a single omic. And this is indeed the case. So we saw that 3 of the factors were significantly associated to the time until a patient needs treatment again. And by combining the MOFA factors in a predictive model, this actually did better than if we just used one of the molecular layers or if we just concatenated all of them in a naive manner without accounting for the structure. Now, in the second application, we made use of the group framework. So far, we only had one group of samples, but multiple molecular layers. In the second application, we now have a single molecular layer, distinct groups of samples. So this is a study on single-cell RNA sequencing, where we had about 16,000 single cells from mouse embryo at 3 distinct developmental stages, from embryonic day 6.5 to 7.25. And we were interested in what are the molecular processes that underlie the developmental decision of a cell, so which direction or which tissue a cell will form when the embryo develops. And for this, we again applied MOFA to this data, now with groups of samples, as you can see on the bottom here, with 2 replicates at each developmental stage. And we can again see that some factors are important for all of the sample groups, while others gain more and more importance as the development progresses. So for example, factor 4, you can see is not active at an early developmental stage, but gets more and more active later on. And if we look into this factor, this actually very nicely captured the emergence of a specific cell type, the so-called mesoderm lineage, at the embryonic day 7. So that's the pink cells here. And these cells will later form your muscles and blood vessels and start to emerge at embryonic day 7. And if you look into the weights of this factor, we can see that this actually nicely links to proteins that start getting up or down regulated with the emergence of the cell type. So that brings me nearly to the end. I just want to quickly mention some related work and ongoing research in this area. So far I've showed you that with this framework of multi-omics factor analysis, we can encode group structures both among the features, such as, for example, in multi-omic data, as well as between the samples, such as, for example, with having different developmental stages. But of course, there are also other types of data structure that can be important, like, for example, for temporal or spatial data, where we have continuous structures among the samples, or if we have network information on the features of the samples. In addition, it might be interesting to look more into nonlinear extensions of the model. So far, we always had a linear mapping from a latent space to the observed data. And of course, strongly nonlinear patterns might be missed by such an approach. And then I quickly want to mention a related approach. So far, we've only looked into unsupervised integration of multimodal data, trying to infer latent factors in an unsupervised manner. However, sometimes we might also be interested in a supervised integration. For example, if we want to predict a certain response of interest, like, for example, clinical outcome, based on different molecular layers. And for this, we've also developed an R package called CRAPER that adaptively weights the different data modalities in such a regression framework in a data-driven manner and tries to give the best weight to each of the data modalities to predict the response of interest. And this already brings me to the summary of this approach. So I've shown you that with multi-omics factor analysis, we've implemented a Bayesian factor analysis model that disentangles the sources of variation in multi-few as well as multi-group data, or both. And it can cope with missing value. It's scalable to hundreds of thousands of samples or features, and it yields interpretable results by the use of sparsity priors. We've implemented a package so that it interfaces with many important or common classes, such as multi-assay experiment container for multi-omics data or the SORAR package. And for model training, we use Reticulate to interface our package with Python, which is a really nice approach to combine Python and R in a nice manner. And last but not least, we implemented various functions for downstream analysis in the package, as well as in the Shiny app, to allow users or researchers to upload the data on the trained model and explore them in an interactive manner. The software MOFA is available from Bioconductor, and the successor, which also has the multi-group framework, is still available from GitHub, and the Shiny app is on our EBI server. And then to conclude, I just want to thank everyone who was involved in this work, especially Ricard Aguilar, with whom I co-authored the package, as well as Oliver Stegler, Wolfgang Huber, Daniela Predikin, and Damian Arnold, as well as everyone else who was involved in this. And I also thank you a lot for your attention. And I hope that I see many of you later in the Q&A session.
Thank you very much, Britta, for the very interesting talk. And also on behalf of the whole organizing committee, I would like to thank you for taking time to prepare a presentation and to be present at e-Rum, even though virtually. Actually, for a pure coincidence, I am about to start a project that will involve multi-omic data. So I've had a look at the literature on MOFA, and I have to say it looks pretty promising, and I'm planning to give it a try in the near future. So if I have questions, I think I know now whom I can ask.
Please contact me. I'm very happy for any feedback.
And yeah, so Britta, together with the other speakers, will be available at the end of this session for a round of Q&A, and I will give you instructions at the end of this session to let you know how you can join it. Thank you again, Britta.
Thanks. Bye.
Bye-bye. And now it's time for me to welcome on stage our second speaker, Emanuele Guidotti, who can join now us on stage. Actually, Emanuele is a special guest together with our next invited speaker. Hi, Emanuele.
Hi, Mirko.
Good morning.
Good morning.
Because Emanuele is one of the 2 winners of our CovidR contest. What was CovidR? CovidR is a contest that we decided to organize as e-Rum 2020 when the pandemic broke out and we decided to go virtual with e-Rum. And the topic of this contest was all sorts of contributions that could be made with R to collect, gather, and analyze the data about the pandemic that just broke out at the beginning of the spring. Many of you have actually probably already met Emanuele and the next speaker, Mark Henley, during the pre-conference event that we held on May 29 that featured a lot of interesting talks, out of which we selected the 2 talks that will follow now in the program. Emanuele is a PhD student in finance at the University of Neuchâtel in Switzerland, and in his presentation, he's going to tell us more about the COVID-19 Data Hub. So without further ado, I'll give the word to Emanuele.
Okay, thank you very much for the introduction. It is a pleasure to give this talk today. My talk will be divided in 2 parts. First, I will give a general overview of the project of COVID-19 Data Hub, and then I will show how to import COVID-19 data directly in R. So let me share the screen. Okay. Okay. This is a joint work with David Ardia from HEC Montreal. So welcome to COVID-19 Data Hub. As you may know, the World Health Organization identified key open scientific questions to tackle the epidemic, including socioeconomic and behavioral risk factors, transmission dynamics of the virus, role of the environment, susceptibility of populations, effective policy measures. To answer such questions, no doubt COVID-19 data are immensely useful, but unfortunately, they are released by heterogeneous data sources in different languages in several formats, and are hardly accessible to the average researcher. The goal of COVID-19 Data Hub is to provide a unified, easy access to worldwide fine-grained data, How to do? We implemented an R package designed to aggregate the data from several sources. We put effort in making everything open source and easily extendable. We need native speakers to search for local official data, understand the data, and integrate the data in the package. We had people from India, Poland, Russia, Sweden, and more collaborating on GitHub. The package is exploited by a dedicated server which downloads the latest data and makes them available on a cloud storage on an hourly basis. These are CSV files that can be used by any client application. The files were downloaded 222,000 times in the latest 22 days. We implemented out-of-the-box clients to retrieve the files. First, the COVID-19 package on CRUN. This is not the GitHub package we use to aggregate the data. This is the CRUN package available to the end user to retrieve the data from our cloud storage. To respect the terms of use, we cannot store World Bank, Google, or Apple data. But we can provide additional arguments to download such data and extend our dataset in real time. We are now implementing a similar client for Python. We published a quick article on Towards Data Science where we show how to quickly build data-driven Shiny apps using our package. Simply connect the Shiny inputs to the COVID-19 arguments. The function uses an internal memory caching system so that the data are never downloaded twice. We do our best to guarantee the data quality and consistency. We keep track of each source for each data. We generate an error log that already spotted 3,000 misalignments in the official data. We rely on the open source community. Everything is open source, code and data. The bigger the community, the faster possible bugs will be notified and fixed. We also offer vintage data, daily snapshots of the data, so to ensure research reproducibility. Our dataset includes standard COVID-19 variables, policy measures by Oxford COVID-19 Government Response Tracker, geographic information to easily plot on a map for data visualization or merge with external databases. For example, weather information, geolocated tweets, etc. Finally, we provide external identifiers to easily extend the dataset with World Bank Open Data, Google, and Apple mobility reports. Governmental identifiers are also provided to further extend the dataset with local fine-grained statistics. For example, for Italy, ISTAT identifiers have been implemented. We support 194 countries, and more interestingly, we support 545 regions and 4,000 cities, but they correspond respectively to 19 and 6 countries. I would like to take the opportunity to ask you to join the mission, support new data sources, and improve the project. I would like to thank Hack Zurich for the support in the very early stage of the project, the Canadian Institute for Data Valorization that is funding the project, and all the volunteers who have joined us. In the few minutes left, I would like to show how to use the Data Hub in R. So let me change to RStudio. Okay, so first we install the COVID-19 package from CRUN, and we require the package. But the only function in the package is the COVID-19 function, which takes care of downloading the data. By default, the function downloads worldwide data by country. So let's have a look at the dataset. The dataset is a long table, including some data, and I will spend a couple of minutes in describing the dataset. So here we have an ID, which is the identifier of the location, the date of the observation, and here we can see the first block of variables, which are standard COVID-19 variables, such as the cumulative number of tests, confirmed cases, recovered, deaths, and hospitalized patients on date, requiring ventilation, and patients in intensive therapy. We also provide the population for the given location. Then we have a second block of variables, which are policy measures by Oxford COVID-19 government response tracker. These are this is a collection of policy measures that are being implemented all around the world to tackle the epidemic, such as the closing of schools or the workplaces, the cancellation of events, the restriction on gatherings, transportation closing, stay-home restrictions, and internal or international movement restrictions. We also have the information campaigns and the testing policy, which is adopted by the government, as well as the contact tracing. And all this information is putting together in a stringency index, which is an index by Oxford, which is measuring how strong the measures are to allow a cross-country comparison. Then we have a collection of country identifiers, such as the ISO code, which can be used to merge our dataset with external databases, and a collection of geographic information, such as the administrative area, the names of the administrative areas. So like the country names, here we have region or state names, which are NA now, because now we are considering country level data, and administrative area 3, which is usually city or municipality. We also provide the latitude and longitude to allow to extend the dataset with additional exogenous variables depending on the position, such as weather information, and which can be useful to study the virus. Also, we have additional identifiers which can be used to merge the dataset with, in this case, Apple data and Google data. Okay, we keep track of each source for each data. So how to access this information? We store the information together with the dataset, and here we have the data. Here we have the table for the data sources. So here we can see, for example, for Italy, you can see exactly all the data sources that are going to build the dataset provided. So Italy, level 1, so national level data. The data type we are interested in, so let's say tests. And here we have the repository from which they are pulled and they're pulled from Ministero della Salute, Italia. By default, we offer clean data. So we do a bit of pre-processing. This means that we download the raw data and we fill missing data with the with the previous non-missing data. This is suited for data visualization, but may not be suited for more advanced analysis, where you are more interested in the raw data containing missing values. This is achieved by setting the argument row equal to true. This will skip all pre-processing and will return you the raw data from official sources. So here we can see exactly the same data set as before, but with NA instead of zeros or instead of the previous value. Okay. Now we can also download state or regional level data by setting the level argument. This level argument controls the granularity of the data. By default, the COVID-19 function uses level 1, so national level data. Level 2 means state, regional level data, and level 3 is also supported, so that you can download city level data or municipality. So let's have a look. And again, you can see that the structure of the data set is exactly the same. What's changing is the granularity. So if we go here, we can see that now we don't have only United Kingdom, but we have administrative areas of level 2. So for China and many, many others. Level 3 is also supported. And also you can filter the data you're retrieving by country. So in this case, we are going to download Italian data for cities, city level Italian data. Again, the structure is always the same. And here you can see that each row corresponds now to a city. Let's have a look at Milano. Okay, Lombardia, Milano, and the latest data available as of today. You can see that the official government is not providing city-level data for deaths, but we are using data from Center of Excellence in Economics and Data Science from the University of Milano, where they are collecting data at city about death at city level via web scraping. So for some cities, we also have, like Firenze, we also have the number of deaths at city level. Okay, this is most about COVID-19 data, but we can extend the data set with additional databases, such as World Bank, for example, which is a very large repository of national level statistics, for example, GDP. So if you're interested in GDP statistics at national level, you can go World Bank, copy the World Bank code, and put the World Bank code here. This will download and extend our dataset with World Bank Open Data. In fact, here you can see GDP or the number of hospital beds. Also, you can extend the dataset manually by hand, since here we are offering also key identifiers at city level or state level. And these are usually governmental identifiers that allows you to merge this dataset with local fine-grained statistics. You can also extend the dataset with Google Mobility Reports. So you will see here there are change in the residential occupation, workplaces, transit, and the occupation of parks, grocery stores, and retails. And you can also extend the dataset with Apple Mobility Reports. Everything I showed is available in the COVID-19 documentation and in the examples below. Finally, we have the website where you can directly download the data in a CSV format together with the error logs and the vintage data. Here, it is available the documentation of the dataset that I quickly went through now. And what I explained is the R package API to the COVID-19 Data Hub. We also have a Python API and some instructions for other programming languages. If you're willing to contribute, don't hesitate to join us on GitHub and implement a new data sources. We implemented a quick tutorial to help you get started. And thank you so much for your attention. I hope you can find this dataset useful.
Well, thanks a lot, Emanuele.
Thank you.
Both for entering the competition of CovidR and for being here today to present. We really believe that the R community can give a great contribution in trying to understand the trends and the situation in the world around the current global pandemic. And what we really need really desperately is indeed a centralized place where we can access data and also, of course, good quality data. So we think that the work that people like you and many others are doing is really useful, and yeah, it's helping the world in a sense.
Thank you so much for your words. That's exactly the motivation behind the work.
All right. So thanks again.
Thank you.
And so a little technical note, you may have heard earlier a little bell that chips in every now and then. And I have been told that I should actually warn you and explain you what it is. So it's just a signal for the speakers that tells them that they have 3 minutes left for their slot, for the slot allocated to their talk. So If you hear it, don't be scared. It's just a technical way that we devised to avoid interrupting the speakers. Now, I would like to welcome on stage our third speaker, Mark Henley. So together with Emanuele, Mark is the other winner of the CovidR contest that we held at the end of May. Hello, Mark.
Hey, Mirko, good to see you again. How are you?
I'm good. And you?
Yeah, good, thanks, good. Yeah, I wanted to say thank you so much to you all for having us here, to the organizers who have just done such a great job to adapt to this virtual conference. And I was just looking earlier at all the different international flags, and it's one of the real silver linings that we've all been able to come together like this.
Yeah, I think the real added value of this virtual conference that, to be honest, we had to rearrange in a blink of eye. We had a couple of months to basically reframe everything in a way that we try to keep as close as possible to the physical event that we should have held in Milan. Is that it has widened very much our reach, and now we really have people from all over the world that maybe wouldn't have been able to join us physically in Milan, but now instead they can be here. We also have really presenters from all over the world. As a matter of fact, you are in Oceania, if I'm correct.
Yes.
Am I?
That's right. You can see it's my time.
So you are really on the other side of the world. And we're very happy to have you here. So Mark is a lecturer at the Center for Big Data Research in Health of the University of New South Wales in Sydney. And today he will present us his work on the R package COVOID that is indeed one of the two winners of our CovidR competition. So I'll leave you now the word to you, Mark. So please go ahead.
Awesome. Thanks, Mirko. I'm just going to share my screen. And I hope you can see my slides now. And
yes, now we can see it perfect.
There we go. Now my video's off.
Yes.
Okay. So thanks for the opportunity to talk about COVOID. COVOID is joint work with my colleagues, Oisin Fitzgerald and Tim Churches. Tim, Oisin and I live and work on Gadigal land. The Gadigal people of the Eora Nation are the traditional owners of the land. And as is customary here in Australia, we'd like to acknowledge and pay our respects to their elders, past, present, and emerging. And we particularly extend that respect to any Indigenous community members joining online today. We'd also like to thank Ian Sharp, philanthropic supporter of UNSW, and Ian's really generous work has facilitated our work on this project. Okay, so what is COVOID? COVOID stands for COVID-19 Open Source Infection Dynamics, and COVOID is an R package that provides users with a set of tools for modeling COVID-19 while incorporating time-varying interventions. So users can choose from 7 different epidemic models. They can specify flexible time-varying interventions and then go on to compare future projections under different scenarios. The package also includes a Shiny interface to help users quickly orientate themselves to the workflow. So kind of like Emanuele, I'm going to have a 2-part talk where I present a little bit on slides, and then I'm going to demonstrate the workflow using the Shiny app. But before getting into it, I just want to talk about our motivation. So obviously, how our governments respond to this pandemic has really profound health and economic consequences. And because these decisions are so important, it's imperative that the underlying models and the assumptions are explicit, and that those assumptions really should be transparent and open for us to debate. Ideally as well, the model should be open source and reproducible so that other research groups can replicate and interrogate results. Now, As you guys will all have seen, highly influential modelling from Imperial College London has informed policy in the UK and internationally. Here in Australia, the pandemic response was informed by similar epidemic modelling. But in both cases, the authors were slow to release the modelling code, and particularly in the case of the Imperial College Code, it was heavily criticised, described here as a 15,000-line file that had been worked on for a decade. So obviously not the best practice for reproducibility. And our project really started out as an effort to implement similar models in a way that would be transparent, open source, and reproducible. And with these goals in mind, the R language was a natural platform for our work. And very early on, we decided we would try and release our work as an open source ORG package. So I'll talk you through some of the features of the package. Currently, COVOID allows users to choose from 7 different variations of the standard SI or compartmental model. You may be familiar with this type of model, but if not, a brief explanation is that everybody in the population is assumed to belong to one of these compartments. In the most simple case, the compartments are susceptible, infectious, and recovered. Assumptions we make about the disease pathology, for example, the OR0, the basic reproduction number, define a series of ordinary differential equations that govern the rate of movement between these compartments over time. Now, we can use out-of-the-box tools to solve these equations, and that gives us the number of people in each compartment over the course of the pandemic. The simplest models implemented in the COVOID package are like this. So they're the 3-compartment SIOR models, but there are much more nuanced models that incorporate additional compartments to better reflect reality, such as for people who have been tested, quarantined, and hospitalized, and so on. Next, I'll just show you some really basic syntax for how to implement the simplest SIOR model. Just to give you an idea of the minimal set of parameters you need to run one of these. So first of all, you start with the model parameters. In the case of this really simple model, it's just 2 parameters. So OR0, the reproduction number, and gamma, the recovery rate. And the second thing you have to define is the set of initial conditions. And that's the number of people in each compartment at day 0 for your model. You can then pass these 2 lists to the simulate function. There are many different flavors of this simulate function corresponding to the many different variations of this model that are implemented. And that's it. Once you run this, you can then plot the results, and you get something that looks like these epidemic curves that you'll have seen a lot of lately, which show basically the number in each compartment over time. And the underlying data is also passed to the user if the user wants to further process that. So that's a very basic implementation. Now I'm going to talk about some of the features that make our more sophisticated models interesting. First of all, these are age-structured models. Now, because age is a key determinant of disease transmission and prognosis, several of the models account for population age distribution, as well as the estimated social contacts between age groups at a country level. And the package has built-in functions that allow users to quickly source this information, and that's available for over 150 countries, and it's all shipped with the package. I'll give you a little example of that. So this is using the helper function import age distribution for the country, for Italy here. And all of this data is UN data. It's coming from the World Population Prospects, but these functions allow you to quickly access it. By way of comparison, here's the age distribution for Ireland. So Italy and Ireland. You can see Ireland has a much younger age distribution. Italy is older, and you can imagine how that's very relevant, particularly with respect to COVID-19, that particularly affects the elderly. Okay, so as well as age distribution, the models can also account for the average number of daily social contacts between age groups. These contact matrices are sourced from the Polymod study, and this here is an example of using the helper function import contact matrix to get the social contacts matrix for Italy. So as you can see, contacts are highest between same age groups, so you get that diagonal, and highest contacts for the teens and 20s, unsurprisingly. And again, just by way of comparison, here's the same matrix for Ireland. It's a little bit subtle if you're just looking over the screen, but if you interrogate this, what you can see is that Ireland has much lower social contacts, especially between different age groups. Next, I'm going to talk about another standout feature, and that's the ability to specify flexible time-varying interventions. Now, during the early stages of the pandemic, these type of compartmental models were used to support policies to flatten the curve. However, once the curve is flattened, the question becomes, how soon can we reemerge, and under what conditions? So to help address these questions, the models implemented in COVOID allow the user to specify flexible time-varying interventions. Interventions can target two facets of infection dynamics that can be influenced by policy. The first is the number of daily contacts. So that emulates things like working from home, social distancing. The second thing that's amenable to intervention is the probability of transmission. And that emulates things like wearing masks, washing your hands, and other good hygiene practices like that. So the user can specify these flexible interventions just as a vector in any flexible way, or they can use the helper functions. And this is an example of one of those functions, the contact intervention. And this specifies an intervention that would reduce the number of contacts by half, but does so in a way that it takes about 20 days for that measure to be fully implemented in the population. Now, all of this functionality is available in the downloadable package, but there's also a Shiny interface available that you can call from within the package, or is also available online on our Shiny Apps Hub. The interface is a good way to get started and get an idea of what's available in the package and the workflow, especially for non-coders. So I want to use my last few minutes just to demonstrate some of the workflow with the Shiny app. And here we have it. I hope now you're seeing my Shiny app. There's a lot of things going on here, so I'm going to just highlight some of the more important things. First of all, down the left-hand side, you've got a variety of areas that correspond to the workflow for this package. And we're in the area particularly for parameterizing the model. And here you can do things like choose the country and age distribution. You can specify the initial conditions, so how many people in each compartment on day 0. And you can specify the model parameters. So for example, the reproduction number. That's all I'll say about that for now. I'm just going to go ahead and run a simulation based on these default parameters. Now, once again, there's a lot going on the screen. So I'll just draw your attention to the lower plot here. And we've got a plot with 2 lines. This is showing incidence. The blue line is the model estimated incidence, and the gray line is the actual observed incidence over the last few months in Italy. And as you can see, the model is doing pretty well over the first few weeks, but then it kind of goes into this realm that is outside of reality. And the reason for that is because the model at this point is not taking into account any of the interventions that actually happened in Italy throughout late February, March, and April. So the next thing we're going to do is go ahead and define interventions. And the first intervention I'm going to define are exactly those interventions that have happened. So we can do that in this screen. And this is a little point-and-click tool that allows you to specify flexible interventions. This pink bar represents what would happen if we had no intervention. But I'm gonna use the tool to illustrate what happened in Italy. And we know that in Italy, the lockdowns started in February, quite slowly initially with the Lombardy region. And I'm just representing that by clicking dates and points. You can do this more exactly when you have more time. And we know that it increased over the course of March to the point that by the end of March, there was a very stringent lockdown in Italy. And having specified that intervention, we can now run the simulation again. And we can watch our little undulating COVOID. And now we can see we're getting something a bit closer to what actually happened. I'm going to stretch out the timescale there a bit. Okay, so now our blue line, which is the model prediction, is looking a lot closer, not perfect, but better to what actually happened. So I'm going to save that result. And this is the kind of recommended workflow, is that we're first calibrating to what actually happened, but now we want to go out and see how the future looks. So we can extend the time frame here. With the intervention I specified, I assumed that that intervention would stay in place in Italy for the rest of the year. Of course, that's not going to happen. So now we can start thinking about what's going to happen next. And this is the real power of the app, that you can start specifying different interventions and see what happens. So I might specify that we'll continue in lockdown until July, but then gradually reemerge such that things are back to normal, perhaps by the middle of October. And it's very quick and easy to do with the point-and-click tool. Now let's update our simulation. And no prizes for what's going to happen here. I've said we're all going to go back to normal. We're going to be back eating ice cream and visiting our grandparents. And when the model converges or the simulation finishes running, what you see is that we're going to get this second spike. So you can do much more finessed interventions and explores what happens under different scenarios. The final thing I'll do with my final minute is just to flag the report canvas. As I've been creating these different models, anything that you see on screen here, I can save to the report canvas using this little feature. And then you can come to your report from canvas and revisit the models. You can look back at what you've done, and you can make comments about the interventions that were implemented. And then when you click download report, that will knit it together and just give you a quick knitter report that summarizes the different interventions you've explored and the outputs under those interventions. So that's a quick demonstration of our COVOID Shiny app. So I'll stop sharing the screen now and turn on my video again. So thanks so much for your attention. Tim, Oisin, and I are all going to be available in the Q&A later. So please do jump in and let us know if you have any questions.
All right. Thank you so much, Mark. And congratulations, actually, for winning CovidR with the impressive work that you have been doing. I actually see now that we have almost 700 people who are following now online. So it's definitely more than probably the capacity we would have had at the physical event in Milan. So quite impressive, I have to say.
That's amazing.
Yeah, okay. Thanks again. And now I would like to welcome on stage our next speaker, Edwin Thoen. While he joins, I would like also to say that I'm seeing that a lot of you are actually tweeting about e-Rum and also expressing their appreciation for how the event is going so far. And we're really happy to hear your positive feedback, and keep on tweeting. Hi, Edwin.
Hi, Mirko.
So actually, by pure coincidence, that's the second coincidence of this session. Edwin and I have never met, but we happen to be in the very same city. So this is really the power of e-Rum. It's bringing together people from all the world, but also people that happen to be in the very same city.
Yeah.
So
I guess it's my fault because I fled academia.
So basically, we're in the beautiful city of Leiden in the Netherlands.
Yes.
So Edwin will be our last speaker for this session, after which we will have a Q&A. And Edwin works as data scientist at the Dutch housing site Funda. And today he will be talking about how to build data science products in an agile way using R. So please, Edwin, the floor is yours.
Thank you very much, Mirko. Then I'm going to I'm not seeing my presentation as of now, so maybe if I...
Yes, I can confirm that it's not yet been.
No, I cannot see it with my. Let me. That is a pity.
Yeah.
Let me really quick try to find a workaround.
Yeah, so while we fixed it, for those watching, Hopin is actually a great tool, but it comes with some technical things that we need to manage.
Other things too.
Okay.
And if I go to play mode, is this all right?
I can see, yes, that's working perfectly.
And if I go to the next slide, is this working?
Yes, that's perfect.
Okay.
Indeed. Thank you.
And then I need to hide myself, right?
Yeah.
So
Great.
I will do that right away. Okay.
Thanks.
Sorry.
Yes.
Sorry for this quick.
No worries.
Small delay.
It's the first time for everyone today on Opin, so.
All right. Yeah, I think it's due to preview on Mac. So for the further speakers, please be aware. Okay. I'd like to start with a recipe for disaster. And we take the following ingredients. You need one statistics master of science with no software engineering skills. You need a consulting firm, one customer side, a bunch of project stakeholders, one ill-defined project, a handful of undocumented databases. So with the ingredients, you do the following. The preparations are: use the consulting firm to sell the statistics masters at an experienced data scientist, place the data scientist at the customer side, have the stakeholders convincingly explain the project and set a deadline in the far future. Be sure the data scientist starts trying a great number of models and algorithms that gradually simmer for a couple of months, and as soon as the project implodes, you know it is done. And this is, of course, not a randomly chosen description of a data science project. This is how I started my own career. This is unfortunate, but I think many practitioners in commerce, but maybe also in other applications, can relate to this. In spite of all the goodwill that we show and all the hard work that we put in, our projects often change very little in the company or organization we work in. And we probably have no trouble finding promising relationships, but somehow we seem unable to have these results being implemented. So a quick browse on the web learns that an estimated failure rate of data science projects is about 85%. I will quickly introduce myself before I go on, because I also think it is fundamental for the rest of the talk that you know what I'm working on typically. So as Mirko introduced me, I'm a data scientist at the Dutch housing site Vinda. And I have now about 6-7 years applied experience. So these descriptions at the introduction, that was at the very beginning of my career. Hopefully I've learned a bit in that in the time being. And I mainly focuses on large machine learning projects. So that's what I will be relating to mostly. So just that you know. And also I do some quick research. In software design, there too is a problem of projects that do not really fulfill their promise. A methodology called waterfall was the norm for decades, and it prescribed that a product should be completely finished before it could make it to production. This caused long durations of software development, with projects sometimes running for over a decade, and it led ultimately to a lot of failed projects. So in 2001, this group of handsome young men came together in a hotel in Utah and drew up the Agile Manifesto. And the manifesto contains 4 philosophical core values and 12 more practical applicable principles. And in this talk, of course, we're not going into detail of all those practical, of all those principles and all those values. That will not be feasible in just 15 minutes. But if you'd like to learn more about them, then you can read the text that I created here. It's my view on Agile data science. And yeah, it's pretty lengthy. So if you've got the time, please visit this link and you will find a, what I call booklet. So it's somewhere between an essay and a book, in which I treat all kinds of aspects of what I think is Agile data science. But for this occasion, let me jump to what I see as the essence of data science. And that is, don't wait with bringing your product to production until you think it's totally ready. It can take many months or even years before this happens, if this happens at all. You probably never think you're completely ready. Rather, as soon as your product is just good enough to deliver some value, productionize it and let the user or the customer interact with it. From these interactions, you can learn what the next best step is and improve to that. I think there is a close analogy to what David Robinson advocates for with respect to making work public. So this is an excerpt from his keynote at our StudioConf about a year and a half ago. And he argues that as long as the work resides on your system only, and it's not brought into the open, it's basically invaluable. And I think the same holds for work within your organization. If it's on your machine only and no one else can access it, you really not have contributed anything. So delivering early might push your panic button. You don't feel ready because, well, you're not really ready. Your reactions might be one of the following, like my R² is only 0.39, or I still have 6 more tabs in my Shiny to make, or my third data source is not connected, or my AUC is not there. What it all boils down to is that you don't want to deliver a low quality product because you're a high achieving, concise data scientist or whatever you call yourself. And I think this is one of the main misconceptions about Agile, is that you deliver early means that you create something of low quality. So if you see the gray box as the ideal product, and let's say the area of the box is the time that you spent on the product, then you want to have a product that is both complete and that is of high quality. So as we advocate for productionizing early in what we call a minimal viable product or an MVP, then many people think that it looks something like this. So that's a product that has already many features, but that we cutting corners on quality. So this is what I call a fingers crossed push to production. But rather what your delivery should look like is this. Only a part of the envisioned product features is implemented, but you don't cut corners on quality. From what I've done and seen in the past, a pitfall for data science work is that we are in explore mode for many months until we think we're ready, and then not really taking care of quality while we're doing all this research. I personally think one of the best things you can do to write high quality software is to do so from the start of the project. So now exactly what are the advantages of delivering early? Why do we want to do that in the first place? Well, first of all, you keep the excitement around your product alive. Often a project is started with the firm belief that it's going to be a game changer for the organization, but then it gradually bleeds out because you as a data scientist might report on the progress, such as AUC or R², or whatever statistic you choose to report on. But in the eyes of the stakeholders, there's nothing happening. And they're actually right. So delivering working software, even when it's far from complete, is much better than just doing all kinds of status updates or status emails or meetings or whatever. So the second thing is that you find out quickly if you're solving the right problem. Let me give a little example here. So say you work for a telco and you want to do churn prediction. So you want to pinpoint which customers are likely to cancel their subscription. So you agree with your manager or another business stakeholder that you will assign probabilities to customers that indicate how likely they are to churn within a month. And then you build an MVP from this within 1 or 2 months with a very simple model. So you just fit a simple GLM, and it's not perfect, but at least we have some kind of value in that we can distinguish the customers that are more likely to churn. Now, you deliver that data set to one of the customer success employees who follows up on the customers, and she discovers that they actually already canceled, or that they are so likely to cancel that she cannot do any interventions anymore. So all this time, you would have been optimizing the wrong problem if you didn't build the MVP. So now you can quickly adjust to this and predict it in a longer time span. And the third advantage is what I call that you avoid weaving a web of complexity. So the longer you work on a project, typically the more complex it becomes. And it's my own experience that when you keep researching for too long, you can create a massive project that contains many scripts, and it's very difficult to disentangle the actual product that should be productionized once you're ready. So the earlier your aim for production, the lower the risk of doing this is. So I hope that I've convinced you a little bit of why it's important to build an MVP and not wait too long with productionizing, even though you don't feel you're ready. Now I'd like to talk a little bit of what is so challenging for data science. This is that other than software development, we have to deal with the uncertainty of yet to be discovered data relationships. So building a data science product requires a lot of research on top of the software development. So where software development is quite clear in what the expectations and the requirements for the product are, in data science, we cannot just outline upfront what we're going to build. And what for me works very well is a two-world workflow. And now you see two phases. I probably assume that most of you recognize the face on the left, which is Marie Kondo, the Japanese tidying up guru. On the right-hand side, you see the Austrian philosopher of science, Paul Feyerabend. And I'm going to explain to you what they stand for. So Marie is the software world, where everything is ordered, structured, and serene, and where everything is right on its place. And the motto of Paul Feyerabend was anything goes as valid science, and he published the book Against Method. And I also think his face is just the perfect representative of chaos and anarchy. So he represents the research we do. In Marie's world, we developed a product. It should be well organized, ideally using the best practices such as documentation, unit testing, writing clear and maintainable code. And of course, this is also where complete reproducibility should be attained, because after all, this is the code that we're going to productionize. Now, in the research world, it's all about speed. You don't want to test hypotheses by adjusting the product code right away. It will take too much time, and if the results are not what you want or what you have thought of, then you have to revert everything, and that slows you down and can get really messy, something that we don't want to happen in Marie's world. So rather, we test the outside the product and only adjust the product code if it appears that the research that we did really had the envisioned effect on the product and improves it. So research cycles should be short, and it's okay if they're quick and dirty. And even low reproducibility is quite okay here. Now, you might think we're already at 3/3 of this talk and you have not mentioned R once. This is an R conference. Well, I'm really sorry that I took all this time to introduce myself, but the good news is that I think the R package structure is ideal for the dual mode of working. Of course, an R package is the way to create a software product within R. It allows for documentation, testing, and versioning, and all other best practices. And personally, this is not, of course, intrinsic part of an R package, but I love Drake that I use to link all the functions that are created within the R package, and you create like this sequential flow from this. So when it comes to software development, R packages spark a lot of joy. Now, what about our grumpy philosopher? What does R have in store for him? And the answer is R Markdown. You can create a dedicated folder with research scripts within the package or outside it, whatever you prefer. And the big advantage is that if you keep your entire product as a package, all the functions that are created within it are at your disposal at all time in your research as well. So you don't have to source scripts or make sure they're loaded into memory in some like non-reproducible way. So I use DevTools Load-All for this, but there is, of course, other ways you can even pack up the package and load it using library. And you can use these Markdown files to quickly come to conclusions. These are outside of your software product, but they can make use of the things you do in your software product anyway. So it's about time for me to wrap up. I'd like to highlight these 3 parts of my talk. We discussed that delivering early and then update continuously can lower the risk of failure to a data science project. We also discussed that it can be very beneficial to mentally and physically separate doing data science research from building a data science product. And finally, out that I convinced you that using the R package structure has the ingredients to create data science products in a very agile way. So thank you very much for attending this talk, wherever you are. A huge thanks to the organizing committee, not only for inviting me, but also for the perseverance you show by organizing still this conference in whatever the way it could be held, even though your own region of Lombardy is hit so brutally with the COVID-19. I, of course, will also be in a Q&A session after this, and if you would like to confirm with me outside the conference, this is my Twitter hashtag. I also sometimes tweet about Agile data science, well, not sometimes, quite often. And once again, below is the link to the resource.
All right, back we are.
We are.
So, well, thanks, Edwin. I think we can fairly say that your presentation really sparked joy.
Thank you.
So I have now a few things to say before we move on to the Q&A session, a few reminders. And actually, before doing that, I would like to thank again all the speakers, Britta, Emanuele, Mark, and Edwin. And there's also 4 persons that I would like to thank specially. Because, of course, there's an organizing committee behind this conference that has involved several people. You can find all of their name on our website. But inside e-Rum, I've been taking care especially of one part, which is the management of the team that coordinated promotion and social media. And I could never have done this without the help of 4 persons. And these persons are Gert Jansen-Willen. Dutch is difficult, Edwin, as you may know.
I find it quite easy.
Yeah, fair enough. Serena Signorelli, Andrea Guzzo, and our graphic designer, Vittoria Toso. So please, guys, join me in thanking them for all the amazing work they did in these months to help us managing the communication of e-Rum, even when everything changed all of a sudden. Another reminder is that if you missed some of the talks or you would like to rewatch them because, well, maybe you were doing something else or you were not focused or you missed something, you can find them on our YouTube channel, which you can reach from the footer in our website. And now it's time for the Q&A session, which will be open up until 11:10. And how does it work? The idea is that you can go to the left tab in Opin and click on the sessions, and there you will find 4 rooms, each of which will be associated with the name of a speaker. So you can join these dedicated rooms where you will find the speakers, and there you will be able to ask your questions and to interact with the speakers. Don't be shy. You can also share your video and audio in these rooms because they work a bit differently from the stage. And yeah, go there and really please engage with the speakers who have really spent time and effort to prepare our talks for today. So I would like to close this session thanking again Britta, Emanuele, Mark, and Edwin. And now we can close this plenary session and move to the session area for the Q&A. Thank you all. Hi, Britta.
Hey.
I just thought I'd come by and check if everything is working technically. I see that we have 22 persons watching. So I'd like to ask to each of them if they want to share their video, because we have a capacity to up to 20 videos. Here. Hi, Federico.
Hi there. Hi, Britta.
Hey.
Excellent presentation. Thank you. I'm just also trying to sweep around and see if people need some help in joining or some courage. I don't know if you want to encourage people to join by promising them stickers of MOFA.
So actually, I also, last night, Federico, I received your letter because Federico is in the organizing committee and is actually the person who has all these stickers. So he has more than me, but I do have some. And I checked the mailbox last night, like after the last preparations, like at midnight. But so here they are. So indeed, but he has all of them. So if you want them, just ask him. Hi, Davide.
Aim for the talk, stay for the stickers, or the other way around.
So is there a MOVA Plus sticker?
No, there's no sticker yet. Sorry.
There should be. So I'm just zooming in this. So it's
You need to lower it, otherwise we don't see it.
stickermule.com e-Rum20. You can get that. There's a promotion from Sticker Mule guys that you'll get 10 stickers for €1. So it's something that you can take advantage of if you want to draft some. I'll be giving some of these later on as well. So and you can.
Those are great. So I guess just to go back to the science a little bit, since we don't have a lot of time.
Yeah. Very good.
I'm sorry, but I wasn't able to join the session from the beginning. So I joined midway your talk, but I read your preprint, so I guess I know a little bit of what you're talking about.
Okay, great.
So I guess one question that I had, and I'm sorry if you addressed this on your presentation, because again,
no worries,
I just missed it. But I was wondering what is your, I guess your perspective on like what is the added value of the other modality that are not RNA-seq, because it seems a lot of the times in your preprint, RNA-seq explains a lot of the variation of the data, and so what's and I guess these like multi-omic methods are much more costly, right, than simple single-cell RNA-seq, right? So I was wondering if you have a perspective on how, from a biological point of view, what is the added value of these data?
Yeah, I mean, especially for single-cell sequencing, it's of course, you're right that RNA sequencing is much more established and much less costly to profile cells. But therefore, we, for example, saw that when we use single-cell NMT sequencing for also reading out methylation information, it's often that in the methylation data, you already see some commitment of the cell towards a certain lineage before you can see it in the RNA expression. So it seems that there's some epigenetic priming in a cell towards a certain direction, a certain development. And that's something you can read out much nicer if you have both modalities, both the RNA sequencing and the single-cell methylation data, than if you would only look at the RNA sequencing data.
Yeah, so I guess it's for developing systems would be very important, right?
Exactly, yeah. And I mean, with bulk data, there are, of course, many applications. And there, I think the costs are also reasonable for multi-omic studies for larger scales, for example, personalized medicine, where we did combine the drug response data with other omics. That's a readout that is very close to the clinics, much closer than just RNA sequencing, because there we can immediately tell how the RNA sequencing goes hand in hand with how patients respond to a drug, at least in an ex vivo assay. And that's, of course, also an added value if you want to later on translate it to clinical approaches, which we would not get only from looking at the RNA sequencing data, where we don't have the information how this links to differential drug responses.
I don't know if you touched upon this in the presentation, because I was, trying to follow this and the technical aspects of the whole thing. But can it also be that, to add on David's question, this added value of multi-omics would be that, for example, you can capture something which is, if the signal is not happening at the transcription level, then it might be something that you will not miss, even if, the single-cell RNA sequencing might be, I don't know, more accessible. So maybe you capture some other layers that are probably having a much bigger role, or at all a role, while transcription is not.
Yeah, I mean, as I said, sometimes, for example, the methylation layers really goes before we see anything in the RNA layer. That would be one example. And then the second point is also that if we have multiple molecular layers, we also often see that if we capture a factor only in one of the multi-omic data sets, it's much more likely to be a technical artifact than if you have something that manifests on all of the molecular layers, which is also maybe one way where multi-omic data can help to distinguish what's like a biological driver that manifests in all of the technologies and what is more of technical artifact that is due to a certain technology, which we would learn as a separate factor for only one of the modalities.
I would have a different another question on this, but I don't want to steal the space from others. For example,
should I read the question from the chat? So we have a question from Friederike David, who asks, "Hi Britta, thanks for the great talk. Would MOFA also be suitable to integrate genomic, methylation, and clinical data when no transcriptomics layer is available?"
Yes, so sure. The method really is applicable to all kind of data modalities. As I said, we've implemented different likelihood models, and depending on your data, you might have to choose one of them. We typically recommend to use some pre-processing beforehand. So most often we use the Gaussian likelihood and beforehand process the data so that it can be well modeled by a Gaussian likelihood, for example, by a range stabilizing transformation or some filtering beforehand. But for genomic data, of course, it might also make sense to use a binary model. And so in principle, any kinds of data sets can be integrated. If you work with methylation data and clinical data, you might want to filter the methylation data slightly down because in clinical data, you typically only have a small number of features compared to what you have in methylation data. And so the model, if you don't filter the data or downweigh a certain few, will more concentrate on the variation in the method captured in the methylation data and not in the clinical data, which typically only is a small number of covariates. So that would be my recommendation for this application. And we've also implemented one option that is still very experimental, but that could be helpful in this case, where you downweigh or upweigh a certain few. For example, in this case, you might want to upweigh the clinical data because it might be very informative, although it's only a smaller number of covariates compared to methylation.
So related to this, so you mentioned that you usually prefer to go through the normal, and I guess this is mainly for computational reasons, right?
Yes, so all other likelihoods are based on some sort of approximations, which also work well. And for some cases, it might have advantage over the Gaussian case. But in general, we saw that the advantages are not too big compared to those using the Gaussian likelihood. And therefore, if there's some reasonable pre-processing strategy that allows us to use the Gaussian likelihood, we usually recommend to do this.
And so another question that is the other side of costs, in a sense, besides the sequencing costs, is computational costs. So I'm actually planning to try the package, but I haven't tried it yet. So my question is, can I, if I have a, let's say, not huge data set, say with, say, 50 subjects, 50 samples, and for instance, 4 dimensions, can it typically be run directly on my laptop, or do I need to maybe access a high-performance computing cluster?
No, with 50 samples, you should really be able to run it on your own local laptop.
So
usually it's case linear in both the number of samples, the number of features, the number of views, the number of factors. So it's really very scalable. If you now move to more large-scale applications, like, for example, single-cell data with 100,000 of cells, then you might reach a limit with your local machine, and therefore we've implemented this GPU support where you can also run it on a GPU, and the stochastic variational inference, which you can use to not always look at all of the cells or samples together, but only at a subset, and then resample the subset, which again makes it scalable and runnable in less than an hour.
That's great. Thanks.
There are no other questions. I would probably then hopping back to the one that I was trying to conceive a few seconds ago. I don't know if it's possible or if it's a stupid idea. Can you, for example, integrate, instead of just the RNA-seq counts, could you integrate the velocity values, say, in this framework as well? Is it something that you've been already thinking of?
That's something we haven't thought about yet, or
but doesn't make sense
yet. But
probably it's just.
I mean, you could of course try to have the non-spliced and spliced versions in separate views and see whether there are distinct patterns of variation. You could of course also use the velocity vectors as an input to MOFA to have this as a feature space. But I haven't explored this yet.
Okay. But it's not just because I'm tired from the last days and this idea is, say, just too out of the universe to be conceived. Okay, cool.
I mean, it would be nice to compare that approach, like the velocity approach, to what you were saying before with methylation being a precursor of transcription, right?
Yeah, exactly.
Those are like two orthogonal ways of looking at the same sort of
Much,
yeah, biology.
Okay.
So I guess if there are no other questions, I have a quick follow-up question to what you said about like the scaling and the GPU. So I guess since you're implementing this stochastic approach with GPU, you must have thought about like, deep learning and all those SCVI or these other like more complex models. I actually really like factor models. I think it's great for interpretability and it actually, I prefer them much more than like this black box models. But I was wondering if you had some comparisons with SCVI or similar deep learning approaches in your, in your research.
Yeah, so we didn't make a direct comparison yet because for MOFA we also really wanted to maintain this interpretability. So I'm also a big fan of factor models, but of course there are now also approaches based on relational autoencoders where we can encode such group structure or different data modalities. And there are recent preprints out there yet which try to also retain the interpretability in such kinds of models, but we haven't looked into a direct comparison of such models compared to MOFA. But that would definitely be interesting to see how they compare to one another.
But yeah, if I can say something on this, I really think interpretability is really crucial here because even just with simpler data sets, you often struggle with going from the actual mathematical results to what does this actually entail for the clinicians? And when you go multi-omic, it's even more complicated. So indeed, I am also a big fan of tools that you can easily understand. And what I really like about the set of tools around MOFA is that there's also a lot of built-in tools to do data visualization so that you don't need to think about it yourself in a sense and do it from scratch. But there's actually good reference also in the scientific articles that show you how you should do it. So it doesn't stop when you have the model output, but it allows you to build on that. Now, I don't know if the room will close automatically or not. In theory, it would close now, but I see that it's still open. So if someone else has any other question. Okay, I see actually a question from Martin Garcia Sola, so maybe we can take it if the room still stays open. So the question is, what would be in that scenario of integration of alternative splicing or polyadenylation? Okay, so I don't think I'm understanding the question. What would be in that scenario of integration of alternative splicing or polyadenylation event in single cell? I think I'm missing something, or maybe I'm reading it wrong. Martin, if you are here, can you join us on camera and explain us? Because please join us with, don't be shy, please join us with the audio.
You can join with audio and no camera if you prefer.
Yeah, exactly.
This is for everybody.
Because I think there's maybe a word missing or something. Okay. Then either just join with audio or indeed, if you could try to rewrite it a bit. Unless Britta got it, in which case you can go ahead.
No, I'm not quite sure what that's heading at.
Well, while we fix that, I have to say I'm pretty happy about how Hopin has managed to handle all the stress tests of all the people online, and also with the backstage, we didn't really have technical problems. We were quite worried about it, and I think it went fairly smooth.
Yeah, it's a really nice platform.
Davide, what was your feeling as a viewer?
Oh no, it was great. Yeah, I didn't have any glitches, so that was good. Yeah, it took a while for me to join. When I clicked on join audio and video, it took me a while. Okay. But that's the only.
Okay, we have the question. So in the case of integrating splicing data in single cell, what would be a viable strategy to use MOFA?
So I haven't used MOFA for splicing data yet in the single cell data. But what we often do is to separate the features not only based on the molecular layer they come from, but also, for example, genomic contents. And here it could be spliced, unspliced, or different isoforms, so that you can disentangle variation, which is specific to some types of splicing, for example, from other types of splicing. So these views which we use to integrate data in the MOFA model are not restricted to only have as a view one molecular layer, but it could also be different types of splicing or different types of genomic contexts or methylation data and so on. So this could be one strategy to work with such data using MOFA.
So I think close this session, because now there's a virtual break about meeting the sponsors that are actually the reason why we've been able to turn the event into a virtual event when we went virtual. So, well, thanks again, Britta, for being here today.
Yeah, thank you very much for the invitation and for joining the Q&A.
Thanks, Davide, for joining here. We'll see you probably soon.
Yeah,
is it today? It's today, right?
It is today, yeah. I want to pitch my session because I think one of the speakers in my parallel session would talk about interpretability of deep learning models for genomics. So since this was touched upon, maybe it's a good segue.
Sounds exciting, yeah.
That is parallel session 4, right?
Parallel session 4 this afternoon, yes.
Okay, perfect. Well,
okay, and see you there. Bye.
See you there, everyone. Bye-bye.
Hello, everyone. I think I can, there's already questions lining up here. So I'm gonna allow you to ask your question by, I think, just clicking on you. So we have nothing seems to be happening. I just need to add the plus, click the plus of the moderation panel, right? Someone from, okay. So maybe there was a coincidence that someone just left, so I'll just try to do it another. It does not seem to be working, and yes, there we go. Mark?
Can you hear me?
Yeah, I hear you. Go ahead.
Hey, thank you so much. It's so amazing.
Okay, thank you very much. So you are now publicly speaking like I am. So everybody in this room can hear and see you.
Okay.
So you can ask your question. Go ahead.
Oh, lovely. Thank you so much. Amazing. Firstly, first nice thing about you is like you're working at Funda. Wow. Yes. And second one, what you delivered is also like wow.
Thank you very much.
I have one question. It's more like Funda related.
Yeah, sure.
I'm not a data scientist. I do love R and I love Funda. And what I noticed, hello, Federico. And what I noticed from Funda now, it is a lot of changes in the market.
Right.
I live in Friesland, and I noticed that there's so much changes, and I would love to analyze them, how the housing market works. And I was trying to illegally scrap Funda, but it's not allowed.
No, we are very restrictive in that.
Yes, and I think, okay, how can I join Funda to be able to allow it? Okay, I'm very curious. I want to understand what happens in the Netherlands.
You're not the first.
Please, the knowledge. Please, how can I, what to do?
You're unfortunately not allowed to, because that data is not ours. The data is possessed by the brokers. I'm happy to talk with about that with you a little after this, because I want to stay on topic, because there are about 100 people joining this who also want to discuss the topic. But there is my email address in my slides, which I will share later, and then I'm happy to send you an email on this. Would that be all right? Thank you. Then we have Nissa, is that correct?
Hi, Edwin. Great.
Hello.
And I've read your booklet. And one of the questions that I do have is, what's the benefit of using the package as a structure or the R project as a structure? Because for my work, a lot of the stuff is more ad hoc and not geared towards going to a production. But the ability to share it and using our markdown files and making reports and then pushing that to our GitHub account so that the research that way.
Yeah.
If you could talk about that, that'd be great.
Yeah, thanks. Great question. I'd like to stress that this is just my take on it, and I think you should really separate like the overall Agile philosophy and then the way I implement it. Which the first one is for me like a real breakthrough, and the second one is mere pointers. So if the R package structure does not work for you, or it's overhead or it's overkill, then please don't do so. So I have a fierce discussion with Miles McBain, like the Australian. He's also very vocal on workflow, and we're both love Drake, and I am very passionate about using R packages, and he's not. So like and we both do great, right? So I think what for me the great benefit is, and then I think his workflow looks a lot like yours, is for me personally, I built this really complex machine learning project that contain so many scripts that I've never really know what I'm doing everywhere. So like the complexity grows over my head. So for the R package structure is for me a great way to actually have everything encapsulated and make sure that everything works together, and also to have everything of that at my disposal in the research scripts. So I think to me the last slide, I think it's the last slide or one of the last slides in which I show the markdown script, where you load that package. That is for me such a key use of the package, and it's also very shippable. So among systems. So if that's all not a concern for you, then don't worry, I would say. Yeah.
Sure. Thank you.
Thank you. So I'm adding more people, and you can also ask questions in the chat if you don't like to come on stage. That's also. Hey, Florian.
How you doing?
How's it going?
I'm in you.
Good.
So I have just a question. So now that you left academia early, I think after you.
I'm sorry, just one moment. I think someone is very loud. So everybody not asking the questions, can you please mute? Or yeah, that will do it. Thanks. Go ahead, Florian.
Yeah. So I want you basically, if you can talk a bit about like using this agile way of working, but in the context of academia.
Yeah. So I can give it a shot. I left academia a lot earlier than you do. You didn't leave it in the first place. So I would say is what is key aspect of Agile is so have a finished product ready. So I would say if you want to do a lot of research, I think if I think back of my own thesis and stuff like that, and that was not publishable. I mean, it was a master's thesis, so I don't know if it still accounts for like higher level research. But I would say continuously have a published article ready. Like that is your product, right? That you work on. So if you do like 150 R scripts and all kinds of research notes and have it scattered everywhere. Have a product that you continuously work on and have that basically. So of course, there's not such thing as an MVP. Although maybe sending in your article for the first time can be considered as an MVP, but I'm not sure about that. I think in academia you would. I think what you keep in mind with Agile is that you always work on a product and not at the last time. I think that's the best I can do for you.
So do you think reading your book then would be useful for academics as well?
Yeah, I think so. Yeah, I think why not directly applicable, but I think it's also meant to trigger your like, how am I doing right now? Is my workflow optimal? Can I do better? So even though it's an introduction to Agile and it's giving some pointers in using the R package structure for building products, but it's not it's not prescriptive. So it means to tickle you in, can I do better? What am I doing currently? Is there what can I take away from this? So yeah, I think we'll take a look certainly at the first part.
Thanks.
So Rita, you're still there?
Yes, I'm there. Yeah.
Yeah.
So thanks so much for your talk. It's was very interesting. I really enjoyed. I have a question related. Okay, sorry, there were my kids in the room.
No, that's all right. I know the thing. Yeah.
Yeah. So I really find interesting things that you say. So not to wait that your work is completely finished. Try to put the quality also if the work is not complete. Can you explain me better what you mean with this?
Yeah. So for instance, shall I just use examples of the things I do myself?
Yes, please.
So there are two products I recently worked on in which I was very stringent on working in this Agile way, building an MVP. And the first one was doing a product at Funda. Funda is the housing site that we work on, that I work for, and it's to provide an estimate for every house in the Netherlands. So you fill in your address, and then we come back with what we think is the current value. So behind that is a statistical model that predicts the current house price from all the sales that we recently had on our website. And this was, for some regions, this was very easy because it's very easy when all the houses are the same. And we have these villages and towns that were built in the 60s and 70s in which all the houses are the same. So we could very accurately, we didn't need any advanced modeling or whatever. And what we did is we built the first version of the product for this cities only. So we knew we had a lot of work to do still, but we could already test if people find it valuable to have an estimate. So this was a combined, so the data science was only a part here of the product because it was also like the front end and the user interface. But we could also test already how people conceive this product. And from there, we got feedback and say, yeah, but you don't take into account the size of my garden. So the first thing we went to, so there was not only statistical modeling, it was also very much user experience in, do people feel that we accurately reflect the characteristics of their house into the model. The other thing I recently worked on was classifying our users in different, what we call stages of the user journey. So people who want to buy, people who are already visiting houses. And what we started with is that we provided, so this was more a model for our colleagues. So there was not a product that we brought to the customers, but our colleagues are the customers. And we start with doing high recall only. So precision is still low, but we have high recall. So we can set aside one group that we are quite sure of that are highly likely to visit or to buy a house already. So we still have a lot of work to do. Actually, we are in the middle of this. But For the moment, we can already set aside a part of these users and provide their colleagues with that and say, do you find this useful already?
Okay.
So you need to be a little bit creative. And it's something against your nature, against everybody's nature, and especially the nature of people like us who are very, want to do it right? Because otherwise we wouldn't make it this far in learning R and doing data science. So I guess, it's a bit scary, and that's good.
Yes, no, in fact, for this I was to ask you, what really do you mean with this? Because sometimes you think that you should deliver a very quality product, but that should be finished before to show someone else. So this is why, but now I understand what do you mean. So now it's more clear.
So there are two parts to the quality. There's the model quality, and that you want to have perfect, but it's never going to be perfect. Because if it was easy to model, they wouldn't hire you in the first place. They could just do it by a business rule or something. And secondly, there is the quality of the code. So that's maybe a distinction that was not clear. So the code quality should be really good from the start.
Okay, thanks.
Thank you. So I have Filippo coming on stage. Filippo, are you on stage for the organizing committee or?
Hi, Edwin.
Hello.
Oh, I'm here to make a question because I was in your. So
okay, cool.
Thank you very much. I'm interested in asking you if you can suggest some, I don't know, books or any contents that can help in teaching Agile approach to students, because I'm facing this issue with data science students who are totally unaware of how to manage a project and of the approaches that exist.
Yeah.
So if you have something to suggest would be great.
I did not really write a book on it, nor did I take it. So I was very lucky that I started working at a company that had fully embraced Agile working. So they work Agile for years and years. So they use Scrum and stuff like that. I learned just a lot from Googling, like going into a Google thread in which you go to go from block to block. It also depends a little bit on what you want to. Do you want to have them to have a formal education in Agile? Because there are of course all these courses and things like that, and I'm pretty sure there are books on there, but mostly I just learned from Googling and mainly doing. So what works and what not. So theory is nice to have as a foundation. But I think what you could do best is just this Agile manifesto with the core values and principles, and interpret that with them. Like this, it's a very short text. I think the manifesto, I think it's 68 words, and the principles are like one or two sheets of paper, and go over with them and say, what does that mean for you? How can it help you? Because in essence, it's not much what is Agile, but it's more the application of it than the theory.
I think Filippo has some kind of connection issue.
Yeah, either he has a connection issue or he's startled by my answer.
No. Or both.
Or both, yeah.
Or he went to read the manifesto right away.
Yeah.
Could be another.
I think there are questions in the chat. I will answer them as soon as we are done with this.
Or you can also, I don't know, if people are, say, if you can, say, if you are in an office where you can freely join by video and audio without disturbing others, you can do so by clicking on the upper right corner of the windows where you see our faces, and then ask Edwin to join by audio and video, and
I'll be available entire day.
Exactly. So basically, it's more like it's just a classical "mind if I join you" question that you ask at a conference if someone is at the round table. So
that's at the people tab, right?
Exactly. That's just say before the people tab, before the chat polls and people tab, you will have this. You don't see that now, but okay, exactly. So someone managed to do it successfully. Hi, Luke.
Yeah. Hello. I really enjoyed the talk, the session. I'd also try to apply these principles. Now every project is a different set of features that you implement first. My question is a little bit off topic, but you mentioned the Drake package. And you said some very nice words about it. Can you give a short introduction on how you use it and what it provides for your projects?
Yeah. So basically, what Drake manages for you is the outputs of what function are the inputs of the other, right? So I create everything in functions.
Right.
That's why I use the R package structure. Actually, one of the reasons I use the R package structure is that it enforces me to use functions, because otherwise it won't load if they're just random code in there. And then it's not clear from the function itself which function should be called, and then the output should be piped through another function. So typically you build some kind of pipeline, right? That your data flows through. And basically Drake builds this pipeline from all the functions that you create in the R package.
Similar to what make does, but for R.
Yeah, it's a make file, but and also it caches the results. So that's also very nice. So if you have functions that run for a long time, it only will run again if the functions or the results are no longer valid. For instance, if you change something to the code of the function that runs underneath it, then then it needs to be recalculated. Or if the input value, so it trickles down. If the input value does change, then it also knows that all the output values that depend on it also needs to be recalculated. So it's basically your bookkeeper.
Good. I just didn't understand exactly how. So, for example, now, right now, I'm building a Shiny app where I have all my functions in separate R scripts. And then the beginning of the Shiny app, I just source them in. Is there a way this could help me?
Yeah, you don't need to source them. If they're all in a package, you just load your package.
Right.
So you can. So there are many ways to do it. And the one thing, so I don't do Shiny a lot. And if I do, it's quick and dirty just for one or two stakeholders. So I don't do productional Shiny. But you should definitely get in touch with Colin Fay. He's going to talk also tomorrow. He did the Golem package, which actually enforces you to create a package around your Shiny. That's the guy to go to with these kind of questions.
Okay, thank you very much.
Thank you.
That's valid if you want to buy into modules. So I'm an old styler, so I do Shiny, not so much production, but say I do Shiny and packaging. So still, yes, I would say that the packaging way is the way to go. So I don't know if Colin listens to me and he will bash on me afterwards because I talked bad about modules, but so somehow that no, okay. Okay, I thought it was just showing up here. So I don't know.
That's him. Like with the
A, yes, exactly.
Yeah, with an A, yeah.
He will be another invited speaker, and I guess he will talk about these topics.
I would assume so. I have not seen his abstract, but yeah. Okay. Will there be any?
I have a praise for you for not letting me be the only one later with a Marie Kondo meme in the presentation.
Yeah.
Because I'll also have it, and it's all.
You will.
Yeah. It's about data interpretation and whether that does spark joy.
Okay.
The eternal iteration that you might have. So.
I must, in all honesty, don't really know her.
Me neither. I never any episode of this tiding.
No, I've never seen it, but I was discussing with my wife who could be a good representative of this, because of course the philosopher came from me. But my wife suggested her. She did watch some of the Netflix things.
Yeah.
I do remember that once she saw it, I had to fold all the baby clothes in a strange way. So that's the only association I got with her. But I like her picture. She looks very serene, and so that's
probably not because she folds clothes in that way, but so we're not talking about causality here. But,
yeah.
Hi, Simon.
Hi, Simon.
Hi. Thank you very much for your talk. Very interesting. And I've also been focusing a lot of on reproducibility with packages. But my problem was, I also use Drake and I absolutely love it. But my problem was to get Drake to work well with developing an R package in the manual of Drake, but it never really worked out for me. If you had any hint that how to get that properly.
I personally keep Drake out of the package, so it's not part of the source code. I have the package in which contains all the functions, and then the Drake scripts are basically the run scripts. So in which the plans are formulated and also called. So that is the Drake folder. So if you see in my presentation also, I have a Drake folder that contains the plans and everything. That is not part of the R folder. So the R folder contains all the source code.
No, I do that too. But for example, let's say I want to produce reports that make use of the R package. With the load all function, for example.
Yeah, you can do that at, I don't know the argument at heart, but there is an argument, I think it's called pre-work. So if you have the, now I need to think, and that's not a good thing. You make the plans, so you make the plans, and then you call make, right? And in the make, you have the pre-work argument, in which you can do DevTools load all with the package. So it has all the functions available within the make call. Yeah, it's pre-work.
That didn't really work. Like I had real proper reproducibility issues, and that's why I moved away. I mean, for me, it's not as necessary. I don't have as many functions.
Okay. I think it's minor because it's not difficult. So I think maybe I don't know how long it is ago. I think Drake is getting a lot more stable recently. So there's a lot of work put in.
Another try.
But yeah, sometimes I have some word things that I don't understand either. I must admit with Drake.
I don't know how. When was it? Is it the one from Will Landau, right?
Yeah, that's right. Yeah.
I think I saw that initially developed, say, 4 or 5 years ago. It was pretty much in the conception, but I might be wrong about the timeline. And again, so now it's pretty much stable and also well praised by people. Say it's usable for production.
Yeah. You could even. But that very much depends on the product you're building. You could even just use Drake for developing, but not productionize it. Because in developing, you continuously iterating. So you creating more and more steps, like doing data preparations, doing whatever you're doing. But then it's quite heavy as a dependency also. So that's why in one of the things that we productionized, we decided to ditch Drake because it was no longer necessary, because it's very easy to keep track of all the dependencies as you're developing, but as the things has crystalled out and if it stabilizes, then it's okay to go without it. But it's so difficult to make generic claims about productionizing data science software because it's so diverse, and that probably everybody here is doing things I've never thought of.
I've got a question for you, Edwin, if no one is already asking.
I think there's someone queuing up, but go ahead. I think I just admitted him or her.
Okay.
Hi.
Yeah, there's good. Hello.
Yeah. Hi, my name is Fee. It's a bit confusing. I have a question about agility and also how to get buy-in from not the developers. I think that's for developers, Agile makes sense. I've been also a software developer and found it really intuitive, but more for the people, the customers or the people you're developing for. Yeah, and so the background is that I work for Correlate. We do data for good projects with nonprofit organizations.
Yeah.
We are not paid for that, so our volunteers do that. And so it's also like there's not so much time either on the organization side nor on the volunteer side. I don't feel like this, especially the shipping early, is really valuable to us. But yeah, do you have any like input how to like make this more understandable for like the clients? Why maybe there's only one button and not everything there? And yeah.
Right. Yeah. So it's something
because it also means like they have to spend more time. I think waterfall is like there's not so much time for the client. They don't have to put so much time in it, right? If you're working agile, you have all those calls and exchange.
Yeah, yeah, I see what you mean there. So it's a little bit like expectation management that they say, well, we asked for this entire feature list, and now you come back to us with just this.
Yes.
Yeah. If the client doesn't understand it, so one of, I think, the key advantages of delivering early, as I mentioned, is create excitement. You basically say this excitement is not created, rather it's met with distrust that you can do it, maybe, that they even think, yeah. If there's really no value in there for them, then then that's a pity.
I think most would see the value.
You cannot force excitement, I'm afraid. Although I try. No, it's. I think if you introduce it very well, like we would just want to make sure that we understand what you mean, and so we started off with doing this first. Something I did not came to discuss during the talk, but was also very important, is that one of the underlying reasons of Agile is that most clients don't really know what they want. So people are very good in expressing what they think they want, but then when you're delivering exactly that, it's not what they want. So the idea is also that once you have an unfinished product, they finally come to some kind of convergence. Is that, oh no, this is what I want, or that is what I want. So hopefully this leads to an interesting dynamic. But if the client's a little bit tough and you still want to do it, you can also choose to do it without delivering, of course, but that would lose a part of the appeal to working in an agile way. But yeah, if you have I would say introduce it very well. So we're very aware. So this is just to make sure. This is just a check by you, and don't make it as a release. Say if this, but we want to see if there's already. Do you feel excited by this? Is this what you want? Is this something that you could work with? Even if it's not yet to their desire, and even if it's not yet gonna be used by them, I think you can still do this.
Yeah, I think that's a good framing, right? Yeah, thank you.
Okay, thank you for your question.
I think is it something that probably say this interfacing with customers that probably have, of course, you have different interests and different backgrounds. So that's I think it's a key skill, especially say if you are in an industry and you have to deliver these products, to understand what they want. It's kind of giving birth.
Right. Yeah.
Kind of
collectively,
and then you get maybe to be kind of delivered to them, and say have them evaluate and assess with a more concrete idea of what they will be dealing with if they go with you, say, the full way. I see that in a different but slightly different, in say similar but slightly different way. Also in academic settings, where you, for example, you try to have I don't know. Of course, everyone wants their analysis done by yesterday, of course, right? But sometimes they've been just hearing or reading about it in a cool paper, and they would like you to just do that. Problem is that sometimes you don't have the ingredients. You just do that, or say you as an analyst, you're not set up completely for doing that. So sometimes I understand that this it can probably lead to some kind of a useless or so not so useful iteration at the beginning. But if you give them something in advance so that they can get their hands on, and probably that plus some kind of skills and or tools to explore their data is an added value, for example, to what you can do to save time in the long end.
Yeah, definitely.
Edwin, I think we are getting close to the starting of the next sessions, but say...
I have no idea about time or whatsoever, so I have you to interview now.
But so we can still stay here if you want, so you can, we will have the introductions. I have a very quick question. I have as a motto for 2020, I have the good enough motto.
Yeah.
Not over perfect, to not over perfectify everything, and then deliver more and deliver probably earlier, and probably not with the full set of features. Is that a third dimension in this quality and completeness, or because
I think it's completeness. I think what you talk about is completeness.
Okay.
I think we as a data scientist or statistician or whatever you call yourself don't make a clear distinction between code quality and feature completeness. So quality is like the thing we should focus more on quality and less on feature completeness. That's what I would say. So write rock solid code that works from the beginning, but then as soon as you and then add the features one by one. And you should get rid of the concept of that there's such thing as being done, or that there's so
kind of never done if we want, right?
Yeah, we're never done if we want, but also as soon as projects that are done always need maintenance, and there are also always going to be like things we find out later that are not working the way we do. Even if something is 2 years in production, there's still going to be bugs and stuff like that.
Or underlying changes in the code of your dependencies, and then say
right, yeah, or you forgot to, I don't know, do something dependency, or so. I had it recently when I upgraded the R version by mistake of a product that was running, and then the RDS files were certainly there was a new version of the RDS files. Apparently,
I think it was these RDS. Yeah.
Didn't even know there were versions of RDS files, so that took me 2 days of happy debugging. But yeah, so get rid of, say, don't think of being. There's no end version of a product. There's only a begin version, and that's the MVP.
Yeah. Okay. Cool. I don't know. So I see that people are gradually leaving this room.
Yeah.
Not because we are saying uninteresting things, but probably because we are about to start a new session.
Yeah.
So, Edwin, from my side, I didn't manage to be there for the testing sessions. Again, thank you for joining us, for giving such a compelling talk, and exciting us about your work.
Yeah, thank you very much for inviting me. I was honored.
Our pleasure.
Oh, so now you're waiting all the time to ask your Finda question, right?
Oh.
Yeah. Go ahead.
Yeah, so please, Mark.
Yeah. Go ahead. Yeah, you can go.
I have a job interview in a second, so I don't know how long I can take.
Yeah. Well, then you have to choose what is more important: your question to me or your job interview.
Yeah, it's a data scientist for ING. So.
Okay. Well, go ahead. Reach out to me later. Anyway, you can.
No, until they call. They don't call yet. So for me, I'm now buying a house since 2 years.
Yeah.
I live in Friesland, and I am sociologist. So I look at people, how they move, and Funda has such a sexy data set.
Yeah, that's why I work there.
The views, like how many people view the houses, the prices now after the crisis are so extremely high. I wanted to buy a house for Vraagprijs 425,000. It was bought 50,000 more, and it's way over market. Normal value of it is 400. Mm-hmm. So I find it like, wow, it's amazing. I'm jealous. Like,
yeah, well, if your job interview doesn't work out, no, we don't have any openings at the moment. But
I don't want to be paid. I will pay to analyze it. I will pay.
Now, just
send an email to HR, and I'm sure if you
No, I was trying it.
No.
Sorry, no. I did it. I was bribing people with strawberries. I had strawberries in the garden. I was promising apple pies. No, I give up. I will keep on loving you from the distance.
How my analysis gets sped up, for example.
I haven't tried that one yet.
Yeah, that's the honey, salt, and almonds. That's a good
Salzmandel.
Yeah.
Yeah, but can you share your insights as a data scientist who sees all this?
Yeah. So what we're trying to do, it's a bit of now I'm getting more serious. As from the funder perspective, we don't own that data. So we got many requests for the data, but it's owned by the brokers who use Funda as a platform. Yeah, bye, Federico. I'll catch up with you later. So that use the platform to sell their house, but not to right. So the data we show is not of our in our possession, so we cannot share it. That's and what we try to do, and that's something we only tried to do recently, I'm afraid, is that we're gonna share more and more general insights about the neighborhood. So the first thing we did is, so we have this Waarde check. I'm not sure if you are familiar with it. You can find it on the website in which you can keep track of the.
I am addicted to Funda.
I'm sorry?
We are addicted to
so you know everything of it. You probably know the website probably better than I do, because I typically work on the data only. So
I know that I don't know. Let's put it this way.
Yeah. So we try to also convey more statistics on general house prices in the neighborhood. So that's something that we're running tests with now. But we have to be very careful, because also housing data is personal data. So there's all the GDPR things that are going along with that. So yeah, we are not and it's something people are getting very itchy about very quickly, sharing data. So it's something we like to do, but it's not we are free to do.
No, but I was fed up with Funda a little bit. By the way, there are tricks to scrape it.
I know.
There are tricks to do so. But I was thinking, okay, it's not allowed, let's not do it. But there are cadastre data, for example, this is available. So I thought this is also possible to enjoy.
But cadastre is not free for the detailed information, right?
Okay, how much detail are we talking about? Because some things are there.
Some things are there.
Yeah. I'm fascinated. I'm like so excited to be able to clearly speak now.
Yeah.
But yeah, what you're touching, and I see you, and I see in the numbers behind you, and it's makes me happy already.
Good.
Yeah. But can you share, how do you work with, if you have time? Because
I do. I have all the time. I'm not. I'll wait here for every question.
How do you work with your team? I was wondering, how does the Funda team work? Are you on your own, or
we have two data scientists. So we're
how many?
Two.
Yes.
And we have 2 data engineers. And
how do you define the difference? Because per company it's different.
So data engineers, they basically take the data from all kinds of places within the company and then store them in one uniform way. So they take all the production databases and then create uniform sets out of which we, but also other colleagues who are interested in management statistics or whatever, or marketing or sales, can very quickly draw insights from. So they are responsible for all the data pipelines within the company and having data available. And we, the data scientists, we build data science products on top of this data.
So analyze it.
We can analyze it, and do a large machine learning projects. That's the main thing.
You were mentioning this machine learning project, and you said some places are clear to establish the Waarde, and some places of the Netherlands are difficult.
Yeah.
I don't know. Have you mentioned which one are difficult? Because I haven't heard that.
No, I did not really, and I don't know by heart. But it's typically the places that have very diverse houses, so that have both small houses with a lot of and flats and stuff like that, and also very luxurious houses. So having that, so we try to keep all the models regional. So we have a model for every gemeente in the Netherlands that continuously updates. And for the so the very uniform places, so things like Lelystad, Almere, Zoetermeer, those are all very, very uniform. So all the houses are the same size, of the same build, and it's very easy to model that. So we based our MVP on that.
No, ja, nee, ik kan me wel. Are you Dutch?
I am, yeah.
Ik kan me wel voorstellen dat het zo is.
Yeah.
Yeah, but Lelystad is also evolving recently.
Yeah, but the most of the houses are still in the same state, same size.
I mean, Almere and are they? Because I was also interested in house market in Almere and Lelystad, and they seem to be like having a new modern, different stadsvillas.
Yeah, and especially Almere is, I think, doing something in that way. But still, it was easy to model, at least. I'm not. So because you model the entire Netherlands, I don't go into the details that you go, because you want to really know about the places. I just want to have my models perform the best they can generally. So I'm not interested in predicting the house of the price of this house exactly, but I would like to have as many houses as close as I can. So I only make generic observations.
Have it ever tempted you, because this is what tempted me like 4 years ago with Funda, to make a regression model on underpriced houses? Did it ever tempted you? You don't have to answer this question on it. You don't have to answer this question.
I've not really done that. No. So it's something that we could, so that to understand what makes houses being oversold, right?
Underpriced, for example.
What do you mean by underpriced? So like the vraagprijs is lower than the bid price.
No, that for example, from regression model, based on the data, you can say, okay, this is the expected value, but the bot is, let's say, 20, 30, unexpectedly low.
I think this is also depends on the. So we have the expected value because we have this waardecheck model, but I think this is also dependent on the quality of your model. If you so, there's also, of course, a misprediction in your estimation model because it's a model. So we know that we can be way off at some of the models. So we did a lot of analysis how we could improve the model, but not how we. No, not really why this is well. So I think for such an analysis, you'd rather analyze where is the what we say the sell price is under the asking price. So where are the asking prices basically too high? What are the determinants of that? Because that's really the what indicates the value.
Yeah.
Not our model. Our model is just an approximation of that.
What I also noticed, I don't have a global view. I have only a small view.
Yeah.
And also local. Unfortunately, please, can I join the data set of yours? But I noticed that the houses, I have seen many houses meantime, and I compared them with Funda. The data on Funda is sometimes different with 20 square meters for when it comes to size, for example. The size of the house differs. And do you have a global picture how often these discrepancies come?
You mean discrepancies between the cadastre and Funda?
Sorry?
You mean discrepancies between cadastre and Funda?
It's not. I don't know if I didn't compare it with cadastre. I compared it with Maitland.
Oh yeah. Then you can. No, I don't have data, but yeah, we have people who are enforcing data quality at the makelars, at the brokers.
Okay, because I did notice there are discrepancies only in a few cases which I could come across, and I wonder how do you cope with it? Because when you have
we just call the makelaar if we know there's an error. So there is there's this button on the website on the house that says meld een fout. So if you think there's something inaccurate, then you just can point it out, and then we ask the makelaar to adjust it.
But I don't think, like, firstly, I'm interested person. I don't feel like clicking it. I don't feel like reporting it. I wonder what is the percentage of people who will report it? This is the first question. So second question is, like, how do you deal with onzekerheid, with the fact that your data is not perfect? That it's like, how do you estimate the error, not having any other information than just like...
With the waarde check?
Yes.
So the input data, did you know that's not perfect?
Yes.
You just, so yeah, of course that causes the mispredictions. But from the, there's not much you can do. So you have to make with what you have. So we trust the makelaars to fill in the houses most of the time correctly.
You assume the data is correct.
You have to assume. Well, we know they're not correct always, but I think that's also very related to Agile. You just do the best that you can do, and you have your cross validation, right? Like I mean, every machine learning, you have your cross validation, and if that then
works, you're happy.
What? Yeah.
If it works, you're happy.
If it works, it works. So yeah, you can go in every nitty gritty, in every detail, what can go wrong, but you just have to be focused on, am I doing okay overall? Does the data science product serve the business need? And if it does, then it's fine. And if it doesn't, so if we think the model is not good enough, then we're going to explore what might be the culprit. And one of those could be that you are actually using wrong data. That happens, and then you're going to find then maybe you ditch that variable. If the variable is really polluted, it's not good, then you try to use another variable. It's very very hands-on.
Yeah, that's really complex also, because then I'm wondering, okay, how do you evaluate? How do you cross-check if you're on the right? What's your reference? How do you know that you predicted it?
Your cross-validation. Your cross-validation always your reference.
Yeah, but what is actually the price of the house? Because this is
the amount that is paid for it. That's what we consider.
Exactly.
Yeah, if we deviate from that, then we're all lost.
Yeah. But then, like, one house, one person wants to pay less, one person wants to pay more.
Yeah.
And
that's called error in statistical modeling. That's something you cannot model, and that's something you just have to accept.
For me, errors are black magic. I don't understand them. I still don't understand.
It's the part that you cannot explain.
This is the part I really would like to understand.
Yeah.
Good. But do you think is there a chance to do a stage in Funda, for example, social maatschappelijke stage, because I find it so pity that Funda has such a great insights about our society. And they're not shared with the government, because it can provide so much insights and the government can adjust the policy. This is how I am a sociologist, so this is my perspective. I want to make society better.
Okay.
If I know, because I'm looking for the house, I know now how people are going crazy with buying houses. But I would like to know if what I see here.
I admire your passion, but I don't know a clear-cut answer to that. But you already sent emails to HR of Funda? Is that what you said?
Yeah, several times I was trying to say, but I have a certain way of bringing things with a lot of enthusiasm, a little fast. So people sometimes don't understand what I'm saying.
No, that's very difficult in the Netherlands, being enthusiastic, I guess.
Yes, I'm quite depressed by now.
Yeah, I understand. Yeah.
When I did data science, I became enthusiastic again, but then I have to come back to the crowd, and then.
Just get in touch with me later. Is that okay? Because
yes, I'll contact you on LinkedIn. So maybe that's also
okay.
Or you prepare an email.
I'm always happy to exchange thoughts. I'm not sure if I can do anything like a stage, but let's. Thank you very much. Good luck with the interview.
Thank you very much.
Bye.
Bye.
Yes, if you have any questions, please just feel free. I'm not used to moderate any session, so please feel free.
I was just wondering if you could share the script you showed, because it looks like an easy way to explore your package, which is very awesome, though.
Okay. Yes. I don't know if Hoping allows to share attachments or files. I don't think so. Actually, the script is on the is basically what's available on the website. Just let me upload on Dropbox maybe, and I will share a link to the file. Okay.
Yes, thank you.
Okay,
Nice.
I will do it
Yeah,
in a few minutes.
Hi, Manuel. Can you hear me?
Hello. Yes.
Hello.
We can hear and see you. Nice to meet you.
That was awesome. That was awesome. So just wanted to ask, instead of really creating a PR, etc., my contribution would best be in your package to offer a visualization choice for anybody who would like to then obviously visualize what they download. So, and that's what I've been working on. Hopefully you will hear it in my speech later briefly, because it won't be about the visualization, it will be about something else of COVID-19. But is that the best? Shall I create a vignette, then send it as a PR, or are we not thinking about kind of visualization yet? That was my question.
Okay, yes, the project itself is really committed to gathering as much data as possible without visualization, because we hope that someone like you, hopefully, will take care of that. So we're putting a lot of effort in gathering the data so that they can be exploited by someone else to create visualization products. So if you like the idea, you are very welcome to join. We already have a very, just a shiny repository where we foresee to implement some shiny application for visualization. But we don't think to include that in the main package. We should be dedicated to data only. At least for now. But then it is possible, of course, to create another package which does visualization based on our data. That's extremely welcome. Yes. Works? Does it work? Okay, great.
I think it makes sense. You probably just want to keep it to the data tiers, and I was hoping. Well, I didn't see any in the API section, but yeah, I could always contribute in the API section itself as well. So yeah, awesome work.
Okay, as you like, but if you are, if you like to create a data visualization instead for COVID-19, you can do it out of the box, just using the package, and create another package on top of that, or also maybe with other languages, as you like.
There is enough already to visualize it. I was just thinking maybe a vignette would help people do that, but
I see.
I could advertise it elsewhere and say here is usage of. I could probably add a vignette to my package, my current package, Geoplumbing, and visualize it there. I'll let others ask questions.
Okay, thank you very much.
Thank you, awesome.
Thank you very much.
Cheers.
Yeah, thank you. Bye.
Oh, Rita Giordano, I should have added you somehow. Okay, or on Slack. Okay, I will share the code on Slack. In the meanwhile, please feel free to just drop in and talk and ask questions. Okay. If you have any question, just unmute or write down as you like. In the meanwhile, I'm trying to upload everything. Okay, I sent in the chat the link to the Dropbox script. Then you will probably upload on maybe on the website directly or on Slack. Hope this works.
Hello.
Amedeo. Hello. Nice to meet you.
Nice to meet you. I just wanted to know a bit more about a thing that you mentioned in your talk. You said that actually you had some pre-processing actually to create the data set, if I understood it well. Can you give me some more details about the kind of pre-processing that you had to perform?
Yes, no, it's very, very basic pre-processing. I mean, we are committed to use the official data and raw data, but then we realized that usually for visualization products or for, I mean, just plug and play out of the box, people are striving with missing values that are raising some errors, some things like that.
Okay.
So we are just replacing the missing values with the previous non-missing value.
Okay.
Or 0 if non-previous missing value is available. That's it. That's all the processing we are doing. And of course, this is not well suited for more quantitative or more advanced analysis.
Okay.
That way, you just you download the raw data, and you have the data as is from the official sources.
Okay. And in that sense, what would you say about the data quality of the sources you had?
You mean with the raw data itself?
Yes, in the raw data. You think that the quality was at least good enough, or several issues actually, or this missing data were the only issue that you had?
No, okay. We are really committed to offer the top quality that we can. So we rely on official data sources, and you can find the link exactly to each data source for each kind of data that we are using. And the point is that collecting this kind of data also for governments is not that easy. So sometimes it happens that they realize they made a mistake in the past. So they are updating the historical data set. And that's why we also offer these vintage data that are basically snapshots of the data set at a given point in time. So I mean, if this is most for reproducibility of your results. So if you're using a data set today, and you are publishing some results with the data set as of today, you can directly link to the version of the data set as of today. So if some government realizes that an error was there, they will update the historical data set, but the snapshot that you're using will not change.
Okay. Okay. Thank you very much.
Thank you. Thank you.
Congratulations.
Thank you. Thank you for joining. And if someone else wants to jump in, I'm really happy to have a quick chat.
Let's see, did this work? Hi,
hello.
Can you hear me?
Hi. Yes, I can hear and see you. So thank you.
I can't hear you.
For joining. No?
No,
oh, that's strange.
Hang on. Let's see.
That's a bit. Can you hear
me?
I
managed to get, I see audio input right, but audio output is not right.
I see.
Let me see if I got.
Yes. Or if you are shy, just type the questions. So for me works are the same. Hello? Can you hear me now?
I can hear you. Can you hear me?
Okay, yes, it works.
Please press the same button. Nothing was different, but now it works.
Okay.
First of all, yeah, congratulations on winning that competition. First of all, what I'm interested in is so you've taken lots of different data sources, right? I think you mentioned some of them are official sources. I'm interested in how are you actually wrangling the data in the first place? Like, do the government give you some sort of API, or are you web scraping? What are the techniques that you're really using to pull that data together? I guess once you have the data together, you merge it. But that's the touch point. What techniques are you actually employing then?
Okay. Yes, actually, we are not. I mean, the techniques are very, very easy. First, we go for CSV files. So most of sources are storing CSV files or on the official website or on GitHub. So we go for them. If we cannot find a CSV file, we try to find some other format they're sharing the data, such that usually Excel also works, and some like Belgium, if I'm not wrong, is basically publishing everything in Excel also. And if not, if we do not have well-structured data, we do not do web scraping because now our package is already including a few sources. So if you're going to do web scraping, we are very afraid that this is not maintainable in the long run, because even as of today, we are using mostly structured data sets. And they're even changing the format of these structured data sets. So actually it's, yes. So just, when changing one column or the name of something,
everything breaks, yeah.
Exactly. So we implemented some automatic testing, and if one source fails, the other don't, of course. But we are going for structured sources. Of course, much data are still in an unstructured formats on some website. So in that case, what we do is to rely on other open source projects that are doing web scraping and maintaining web scraping for us, let's say, and offering that kind of data in a structured format. And then we are pulling the data from that form, from that source. Yes.
Okay. And what frequency are you usually updating this whole data set? I mean, I guess it's stored embedded in the package, right? So how often are you pushing?
Yes, it's on an hourly basis. So each hour we are updating the data files. Actually, the package that I showed is simply a package which is reading files from our cloud storage. Then, yeah. So in this way, we already implemented also a simple package for Python, which is doing the same thing. So going to our cloud storage and retrieving the data in Python. You can directly retrieve this data in Excel. You can just click on the website and download, so it's very portable, let's say. And these files are automatically generated each hour.
Okay, nice. Yeah, so really, really interesting. Thanks for putting it together.
Thank you. Thank you.
Thanks.
Welcome.
Hello, Mark.
Hi, Ashley.
Hello.
Hi, Simon.
Thank you very much for a very interesting presentation.
Oh, no worries. It was a pleasure.
May I start with some questions? I don't know how it works here. So,
yeah, I think that's pretty much it. Fire ahead with any questions.
Okay, thank you very much. So, I have just a few questions about, because I didn't understand very well, which kind of simulation you are exploiting. So it's like just a resolution of the system of differential equation, or you are also exploiting like stochastic simulations like Gillespie or SSA or something like this?
Just before I answer the question, there's a really strong echo. Tim, is that coming from you?
Yeah, I heard a little bit of echo, yeah.
Okay, I think that sounds better. Okay, so the question is about what kind of models are being implemented. So yeah, these are ordinary differential equations. So it's an out-of-the-box ODE solver, DSolve. But so Oisin and Tim, the other people online here, are my co-authors for the package. And Oisin, maybe you can answer that question in a bit more detail.
Yeah, sure. I mean, pretty much just like Mark said, it's just, they are at the moment just the basic, like it's just a DSolve, it just uses DSolve, and it's just, so simulate is really the DSolve is used to solve the equation, and then it's just deterministic from there. So it's not stochastic in any way. You won't get a different answer for for different runs of the model.
Okay, thanks. But are you planning to develop also some like approach in this package, in your package?
Yeah,
stochastic approach.
I guess we sort of like very much like that last talk was a good description of how we worked about the Agile. So that I think you can very much see that package as being, we just wanted a very minimal thing. Our main goal is to have the deterministic models with the age structure aspect, and also to have the Shiny app. So yeah,
the Shiny app is very amazing. Congratulations! Yeah.
That was mostly Mark, but yeah, going forward, I think we'd love to incorporate different approaches to the modeling for sure, and definitely more.
Oh, sorry, I interrupted. Because I was saying this because we develop a very similar package, but to do some like. Every kind of epidemiological model, not just the COVID model, but like every kind of epidemiological model. But we don't have any kind of Shiny apps or something like this, but we are just the error package to simulate and the stochastic, and also to resolve the system of differential equation. And it is very interesting to see how much similar are from the point of view of deterministic process. And we are working with the PetriNets model. I don't know if you hear about that.
What's your package? But just Tim, I'm pretty sure it's because you're not using earphones. That does that help?
The package is called EPI model. There will be a presentation in like 1.5 half hour between.
Yeah. So Tim here. In fact, our first model was based on EPI model using the ICM models, the individual contact models, which is the agent-based, not ODE-based models, but without any underlying network model. But our next step is really to re-implement the models using an underlying network estimation contact model. And in fact, Pavel Krivitsky, who wrote most of the code for the ERGM models used in EpiNet, in EpiModel, I beg your pardon, for the network models, is at UNSW, so he's one of our colleagues, and so we're extending those exponential network models to estimate basically quite complex contact models, and they'll be basically rolled in under the model that we currently have. So we have plans over the next several months to evolve the model to become quite a lot more sophisticated in terms of the contact model, because that's really where the subtleties lie in terms of problems in individual schools or workplaces and so on and so forth.
Yeah. And also on the last question, so I can let you answer also all the other question from the other. There is some like a feature in order to, since you are considered also an age-based model, if there are some parameters that are age-dependent. for instance, there is just the school closure, then you have just the contact of the children that are like 0, but the other are at the maximum rate, something like this.
Yeah. Mark, do you want to answer that? Because I think you weren't able to demonstrate that in the time available.
So the question is about what other parameters are age dependent. Is that right?
Yeah, if it's possible to like give some age dependent parameter or rate.
So in particular for the interventions, yes. So we can target specific interventions by using contact matrices that are specific to schools. So if, for example, you're interested in an intervention that was targeted at younger people at schools, you could apply that intervention to that group while leaving other age groups unaffected.
Oh, okay. Yeah. And is it also possible to, the time dependency is answered.
Hey, Tim, I think, is that echo coming from your end, Tim?
Yeah, I'll turn it off again, sorry.
So, sorry, Simon, what was the question again?
Thank you. No, yeah, sorry, I didn't understand. Can you?
Which bit didn't you, or was it what I had said?
Yeah, sorry. Yeah, I heard it.
So I was explaining about the setting-specific interventions and how interventions can be targeted at schools, homes, workplaces, as well as just general interventions that affect the whole population. So in that sense, they are those are the type of things that can be age-specific. But in terms of other parameters in the model being age-specific, that's not built in at the moment. Oisin, could there be possibility to build in age-specific gamma rates, for example?
No, okay, yes, thank you very much. I understood. So I didn't understand the question. So in our model, if it's possible to build something like this? No, sorry, I didn't understand the question.
So I understood. I thought your question was about age.
No, yeah, you answered to my question. Yeah.
Okay, good.
Thank you very much.
If you want to collaborate, we're very open to collaboration, or even whether it's just exchanging notes about approaches or even working on each other's code. We're very open to collaboration. So just get in touch with us. I think you've got our email address. It sounds like you're working on very similar things.
Yeah, we are working on very similar. So, well, I am a PhD student on the University of Turin in Italy. Yep. But I think we can change some emails if we want.
Sure, we'd be happy to do that.
And I do like very much the collaboration. Yeah, it seems very interesting.
Yep.
And similar. So.
Yes. And, I mean, there's a lot. We now realize that there's actually a lot to do, more than we can just do ourselves. So it's important to collaborate and share the work around.
Thank you very much. Yeah. But I don't know how we can change the email. There is somewhere.
I can send you a direct message, Simon.
Thank you very much.
I'll do that shortly.
Perfect. I will let you to the other question.
Cool. Sounds good.
Thank you very much again.
Thank you. So I think anyone else who is interested to ask a question is welcome to join by video, or alternatively, if you put your question in the chat area, which I have an eye on. But in the absence of any other questions on the chat, maybe I could ask you, Tim, to talk a bit about the future plans.
Yes. So Nina Otapal has asked about the code for the reporting feature, so the report canvas. So perhaps you could get back offline on to Nina about that, Mark.
Yeah, I messaged me. I'll follow up with her.
Okay, yeah. Yeah, so future plans. So at the moment, yes, we're just working on some additions to the current ODE models, and I think further refining the workflow and subdividing it into fitting the model to observe data, and then defining future interventions. Because I think, at least here in Australia, COVID-19 has not been completely eradicated, but it's been largely suppressed. We're getting counts of only 2 or 3 cases per day well, about less than 10 cases per day in Australia, and I think many other countries are headed towards that stage as well. So the question then is what to do while waiting for a vaccine, and we may be waiting for another year at least for a vaccine, possibly longer before it's rolled out. So what we're focusing on is the ability to fit models to the observed data up to the current point in time, and then have a workflow that allows lots of different scenarios in terms of interventions that are much less economically costly than complete lockdown going forward. In particular, implementing models that reflect current contact tracing, so contact tracing and then quarantining of contacts of cases and so on and so forth, which is a much less costly intervention than social distancing or lockdowns. So that's the way forward, but we're also realizing that when the numbers become small, the stochastic nature of transmission becomes important. And this is where the purely mathematical models that we've implemented so far, the ODE models, start to fall apart, because they're essentially deterministic, and even with small numbers, you get fairly deterministic behavior. Where in practice, with small numbers, there's lots of random events that happen, and sometimes there may be cases in the community which take off and form transmission chains. Other times they don't go anywhere. So we are thinking about ways of basically being able to model that uncertainty, which is going to be important over the next 6 to 12 months while we're waiting for vaccines to be available and rolled out. And then I also mentioned before, we're working on social contact network models with Pavel Krivitsky, and they basically are a much finer grained model of social interaction between people in households, at the school level, and the workplace level, in shopping centres, in the wider community, and so on. And these models can actually be estimated from survey data. So there are our current plans, reasonably ambitious. We don't have funding for all of them, but for some of the work we'll be able to continue.
So plenty to keep us busy. So there was a question there from Liam Breesley. And Liam asked, are the impact of interventions in COVOID subject to compliance, or is that subsumed into the effectiveness parameter? Interesting. So the interventions are specified as a proportion of what they were prior to the lockdown. So X% of what it was at day 0. So in that sense, yes, you are incorporating compliance into that parameter. So if you saw in the presentation when I was using that point and click tool to specify these curves, I never went fully down to 0, because I always assumed there was some non-compliance, or not just non-compliance, but people who can't comply because they're essential workers and so on. In the future, we'd like to have more data-driven ways of doing this. One of the ways we'd like, having heard Emanuele talk about the COVID-19 package and their data sets about the implementation or the interventions that are in place in different countries, and the index of those interventions, to incorporate that kind of information so the user could import that directly for their country in particular. But yes, at the moment, that's just subsumed into the intervention as it's specified. So there's another question from Bruce. And Bruce asked, if the implementation of regional differences, e.g. local lockdowns, were occurring in Australia, and how were you including them in your models? So that's a good question. So implementing regional differences. At the moment, the models we've been exploring have taken a national approach. So we haven't zoomed in to local differences. I think they're very important for such a country as Australia, which has some very highly populated areas and then some very diverse expanses. We know, following things in Sydney, that there are some local areas that seem particularly prone to transmission, often areas where there are younger populations. Oisin or Tim, could you elaborate on incorporating regional differences?
So, I mean, the main reason we have kept it to a national level is regarding the availability of data that allows us to construct the model. So, for example, as Mark was saying, we have UN data on age distributions and the polymod contact rate study and its extensions for age-specific contact rates. So that's data availability would be the major hurdle to having very fine-grained, very local models. But I think maybe Tim can talk more about, I think, that the goal for the network models was to have very local descriptions.
So in terms of parameterizing models for interventions and so on, we were a bit overawed by the task of trying to assemble that data. We were aware of the Oxford data and so on, but we just didn't have time to include it until this point. But the Emanuele's package, the COVID-19 data package, really solved many of those problems for us. So we will absolutely be leveraging that package in the very near future to bring in and surface a lot more regional data to allow very quickly specify regional data and sets of regional interventions in the model. But we still have a little bit more work to do on the designing the API to do that at the code level, and then implementing that through the Shiny interface. But that's certainly on our near-term roadmap. In terms of going further than that, as I mentioned before, where we plan to implement a bipartite network model, where the two parts of a network are persons and places. So we will be able to model things such as individuals in households, individuals from each household then going to different workplaces or different schools, individuals going to different shopping centres and other places of social aggregation, and then wider community mixing. And because of the existing work done by a group called StatNet, whose work has been incorporated into the EpiModel package, which is run out of Emory University. And as I mentioned, Pavel Kravitsky works with us, and he's been fundamental in developing those methods. You can actually estimate those network models from survey data. So there's existing survey data that's available, but we also have plans to collect new survey data to inform those models. And that will allow very, very fine-grained models where we can actually model, for instance, closure in individual schools, or a small cluster of schools, or shutting down one particular shopping centre or one particular suburb in a city. But we're not there yet. That's still months of work away, but that's on our roadmap. Okay.
I just have another question here from Mintu. And Mintu asks, can we extend these epidemiological models in a stochastic framework? So I think you've kind of mentioned that, Tim, and that is certainly the case and something that's on the cards.
So our original models, which are, I guess, the current models grew out of, were implemented with epimodal and the ICM stochastic individual contact models. And I think we will end up going back to those basically computational agent-based models when we are at the point where we can introduce the bipartite network contact model underneath it. For the time being, we're sticking with the ODE models, and it is possible to introduce stochastic elements into those. We don't have that on our roadmap at the moment, but we'll probably revert to the agent-based stochastic models. At the moment, we're not actually using epimodal. We've sort of outgrown its framework, but the plan eventually is to fold all of this work that we're doing back into the epimodal package as well as a set of enhancements, or at least submit them as pull requests for that package. So is that a reasonable summary, Oisin?
Thought that was a good summary.
Yeah. So yeah, thanks, Mintu. And once again, we're very happy to to collaborate with others, either whether it's just at the level of ideas, or sharing notes, or actually collaborating on actually writing code, because once again, we think that there's a lot of valuable work that still needs to be done, to make these models really sophisticated models, as we were just describing, available as open source and able to be run by everyone, not just by specialized groups. And there's more work than we can do ourselves. So we're very, very happy to collaborate with others. At this point, I'm afraid it's dinner time here in Australia, so I'm going to dip out and have some dinner. It's 7:20 in the evening. So thanks everyone, and I think Mark and Oisin might be back and around for a little while to answer further questions in due course.
Yeah, well, that's perfect timing because the parallel sessions will be starting in about 10 minutes. So that gives time for everyone to have a quick break before diving into the next session. So Oisin, unless you have anything to add?
For asking the questions, everyone, and thanks for listening to the presentation from Mark. So, thanks, Mark.
Great stuff. Thanks everyone who's watching. Bye, guys.